Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy, pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
Here I am in the heart of our Nord product range. Nord Drive Systems manufactures a very large range of drive technology products. Gear units, electric motors, electronic drive technology and industrial gear units. The overall portfolio is a unique modular system from which individual solutions can be created for our customers. Our most well-known drive systems consist of a motor and a gear unit, the geared motor. Our drive systems can also be extended by frequency inverters. Here we have a decentralized solution, also available as control cabinet version. The most complex systems can be seen here. They are used for higher torques or powers. Nord has therefore developed the MaxDrive Industrial Gear Unit series, including various integrable components. The almost infinite combinations allow for a drive that perfectly matches the requirements. Let me show you an example. This drive system, consisting of industrial gear unit, electric motor and fluid coupling, is mounted on a swing base. You can also choose an IEC motor attachment, use B5, B14 flanges on the output side, mount a modular external backstop installation, and choose many more product options. Here is another example, a typical application, a belt conveyor drive. Consisting of electric motor, coupling solution, industrial gear unit with axial fan for achieving maximum thermal limit powers, mounted on a swing base. Realized from our modular system. Here is a typical application, a mixer drive, consisting of agitator flange, MaxDrive industrial gear unit, IEC adapter for fitting a Nord electric motor, and a decentralized frequency inverter from Nord, vertically mounted from the modular system. And we also have the perfect drive system for you. Nord Drive Systems has expanded its industrial gear unit product portfolio with a new product line. This gear unit can be especially effective for belt drives used in all areas of bulk handling. We are talking about the MaxDrive XT. XT means extended thermal capacity. As indicated by the name, this gear unit has an exceptional property. Compared with many other drives of comparable size, it has a significantly improved thermal limit power. That means very high drive powers without additional cooling can be used with this gear unit. Especially for the bulk material handling industry, this is a great advantage. The exceptional high thermal limit power is achieved by different devices. A heavily ribbed housing with a surface increased by the factor 2.5, a high efficiency axial fan, and a CFD optimized airflow with a corresponding baffle design. The area with the strongest heat generation on the drive shaft is hereby optimally cooled. A CFD analysis demonstrates the strong cooling effect and the optimized airflow, especially in the drive area. Compared to the MaxDrive gear unit, this results in a considerably increased thermal limit power. MaxDrive XT also follows the Nord concept of one-piece housings. This structural principle achieves more accurate axis positions, and the gear unit is more torsionally rigid. This results in significantly higher operational reliability and less maintenance. These unique properties perfectly qualify our new MaxDrive XT for belt conveyor drives. For these applications, Nord offers complete drive units consisting of gear, motor, coupling, brake and swing arm, individually tailored to the customer. This is the optimal solution for drives in mixing and agitation processes, optimized with leading companies from the sector for the sector. To illustrate the differences, let me show you which elements are not required anymore compared to the classic version. Wear-prone and therefore maintenance-intensive seals belong to the past, just like the bulky oil tank. Let's have a closer look at the new concept. Here we have a drive system consisting of gear unit, IEC or NEMA adapter, and electric motor. And this adapter makes the difference. We call it SOFOMI, sealless adapter for mixers. Compared with the old solution with an oil tank, the oil level can be significantly reduced and is approximately here. The lubricant heats up during operation and the volume increases. Thanks to the new solution, drive shaft seals can be omitted. When the lubricant heats up, the volume of the adapter can therefore be used to compensate. For you, this means excellent operational reliability, compact and simple design, fewer wearing parts, improved thermal properties, and hence less maintenance. SOFOMI, always the first choice for new installations and with easy retrofitting.
In the presentation titled Examining the Efficiency of a Jig Concentrating Process of Separating the Coal Dust, Coking Coal Dust within the narrow size grades. I will present the impact of fine grain on the process and present the possibilities for increasing the efficiency of separation. In the majority of JSW's coking coal separation in the size grade above 20 millimeters plants, the magnetized separators DISA type, and in the 20 to 0 millimeter size grade, the coal dust jig concentrators made by the design of KOMAG. The material mainly received during the jig concentrator product using the centrifugal sieves is subject to separation using the flotation process. The efficiency of jig concentrator-based separation coal with respect to the separation is dependent upon a number of factors, including the design of the jig concentrator and the methods of controlling the pulsating flow of operating air and the pickup of heavy products, heavy fractions, the characteristics curve of feed, the uniformity of powering the jig with feeding the feed to the jig. The coking coal feed in the 20 to 0 millimeter of grain is characterized by a very high share of grains below 3 millimeters. This is more than 50%. This is due to the crushability of the coking coal, the way of it is processed, and the lack of desludging. In the majority of jig-based nodes, the feed is not subject to dislodging on the fixed sieves or shaking screens and is entering to a large frequency, including the fine-grained material. The large portion of the majority portion of fine-grained share has a negative impact on the efficiency of the separation process of the coking coal. A significant part in the 20 to 0 millimeter of a small fine grain that fills the space between the large grains makes it difficult to flow for the water, pulsating water through the layer of the material, which may lead to the decreasing the efficiency of its density-based separation due to the increase of the density of the medium, as well as the harmful outflow of air from the inside of the pulsating chambers to the jig working space. A broad range of granulation of coal dust feeds very far from the optimum ratio of 4:1 leads to the need to apply the multiple stage of separation of waste fraction in the subsequent stages of separation, or in the additional jig for the secondary separation of a semi-product. The list of the separation of material in the jig concentrators indicated that apart from the parameter of the feed that has another parameter that is an efficiency of the coal separation process is the way it is delivered to the working tray of the jig. The uniform, the quality and quantity aspect, the flow of the working tray of the jig concentrated on the entire width, the currently applied solutions is difficult to achieve, especially in case of the feed transportation of toward the jigs where perpendicular inflows where the grain is separated based on the speed of floating, and also reduces negatively the efficiency of densifying, layering, foliation of a material, and the accuracy of its separation into products. The negative impact of the above corrections has a negative impact on the efficiency of density-based separation of a material and the split into the products, and can lead to the reduction of its quality parameters while increasing the share of the semi-product and the waste. The negative implications of those incorrections in feeding the feed to the jig increases the breadth, the width of the jig is increasing, and the heavy fractions share is going up. The tests of efficiency of separating the coking coal dust were conducted with a large portion of the 3 to 0 millimeter size grade. The evaluation of efficiency was based on the densification separation in the narrow ranges. The OM24 jig concentrator has a 3-compartment design that enables obtaining the waste product in the first 2 compartments and the concentrate and semi-product in the 3rd compartment. As compared to the existing designs of a KOMAG type jig concentrator, where the width of working trail was between 2 and 3 meters. In the jig concentrated IM24, it is 3.5 meters. During the tests, industrial tests, the load of the jig concentrated IM24, according to the reading of the scale on the conveyor belt, was 580 tons per hour, which corresponds to the heavy load, unit load, of above 160 tons per hour per 1 meter of width of the jig. The share of a 25 to 0 of grain below half a millimeter was significant, 20.5%. Well, about below 3, it was more than 50%, the below 3 millimeter portion. In the density size grade of a total feed, 25 to 0.5 millimeter, the granularity composition of feed was characterized by a high portion of 3 to 0.5, more than 30% share. The share of the other ranges was between 16 and 22%. In the concentrate content, as you can see, was very close to the feed, total feed, and the product was characterized by a more than 40% share of the 3 to 0.5 millimeter. The semi-product was characterized by the 3 to 0.5, 66.3%. The share in the semi-product of the other size grades were similar and between 10 and 12%. The waste product was characterized by the 35 to 6 meter was 63.7% share of this size grade. The results of gravimetrical tests in the 25 to 0.5 millimeter size grade indicated that 67.7%, 5.4% of outgrowth and 32.9% of a waste fraction. But the proportions in terms of the results of tests of the concentrate product analysis, here the concentrate grains, the share was 95%, the outgrowth fraction grain less than 4%, only 0.6% of the waste grain fraction. The waste product, mainly the waste grain fractions, 95%. In the case of the semi-product, the largest share came from the waste grain fractions, with the share being 62%, whereas the concentrated and outgrowth fractions shares were respectively 25 and 13%. For all of the size grades analyzed, the number of the distribution was presented graphically from both stages of the separation process. The efficiency of coking coal dust in the 25 to 0.5 characterized during the first stage was 0.22 grams per cubic centimeters, with a density of separation equal 1.38%. On the second stage of the separation, the efficiency was twice as high, 0.114, with a density of 1.595 gram per cubic centimeter. Relatively low efficiency during the separation of the waste product, so during the first stage of the separation, was due to the low efficiency of the separation of waste grain 3 to 0.5, and the difference in the density of 0.35 gram per cubic centimeter between the waste grain of 25 to 12 and 3 to 6 millimeters. The large heavy section with 0.5 to 3 millimeters was a precondition for achieving the very high efficiency of a separation of 3 to 0.5 in the second stage of separation in the outgrowth segment. By subjecting the granularity and density, the so-called size grade fractions were achieved, what allows for a detailed analysis. The very important element was the fine grain, the finest grain, 3 to 0.5 millimeters, especially the waste fraction on the content and the products of the separation process. During the separation from the feed material, the heavy fraction from the next segments of waste product, the gain was reducing as the size of the grain was going down from 93% in the 25 to 12 millimeters down to 30.7% in the 3 to 0.5 millimeter size grade. Small gain in the heavy product was due to the large portion of waste grain in this segment and the location of fine grain in the outgrowth sections, characteristic for the separation of the feed with a wide, broad range of the phenomenon of various falling of grains. The 25 to 0 meter was preconditions for achieving the high efficiency of the separation of the finest grain due to the possibility of settling in the lower part of the layer and on the surface. Based on the analysis of the process data, we can see that depending the ability to achieve a higher efficiency of the separation of the coal dust in the jigs of the KOMAG type on the increase of the efficiency of separating the waste grains in the 25 to 3 millimeters in the first compartment of the jig concentrated, thanks to the higher efficiency of the separation in the first part of the large grains. It will be possible to inspire the separation of small waste grain in the openings of the mesh, sieve mesh, which allows will be increasing the constant product and the advantageous achievement of achieved semi-product and improvement of its quality parameters as well. In order to achieve a high efficiency of the separation of the feed of the waste grains in the 25 to 3 or 6 millimeters, the process of separation of material in the first compartment of the jig concentration should be conducted in conditions that would ensure the fast layering of the materials after its inclusion in the working section of the working compartment of the working section. Among the solutions that would allow to increase the efficiency of the separation of the coking cast in the KOMAG type jigs would be the modernization of adjustment system in the first compartment, would include the increasing the range of adjustment for the intensity of bottom water flow and the implementation in the jigs that we have a working tray more than 2 meter wide, the double system for extracting the heavy fractions, on withdrawing the double system for extracting the heavy fraction that would enable the independent control of the separation of the bed on the left and right hand side of with the same automatically stabilized level of separation layers, which is especially beneficial when there is a non-uniform distribution of feed on the inlet to the jig. Considering the benefit is the reduction of waste of coal fraction, which is a result of a more accurate control of the separation layer using the two measurement sensors. The double system with the measurement of inlet openings, what allows for the signaling, the indication, the non-uniformity indication in order to take up actions in order to remove this deficiency. The analysis of coking coal dust separation process with granularity of 25 to 0 millimeters indicates that the main factors that have an impact on the efficiency of the production of the coking coal concentrates in the pulsator jigs include the characteristic technological process of the feed, the efficiency of the operation of the jig and its correct operation, the broad range of gradation of feed and the significant, frequently majority share of fine grain material makes it difficult to carry out the process in the jig of density-based delayering and the automatic adjustment of delivery of a product based on the system for the separation of the layers. Increasing the efficiency of the separation of the coking coal, that's with the majority portion of fine grain fraction, is dependent upon increasing the accuracy of the separation of waste grain 25 to 6 millimeters in the first segment, waste segment. The goal of this action is to gain the ability to intensify the surface extraction of waste grains in the 3 to 0 through the openings of mesh, achieving in the single compartment of waste product of the parameters of the close to the in the two other sections requires the use in the first section of the solution that ensure the fast densify based layering of feed material, uniformity of density and also when there is a non-uniform input of the feed. The efficiency of the proposed solutions aimed at increasing the efficiency of coking coal dust separation in the OM type jig construct is dependent upon the uniformity of providing the feed on the width of the inlet to the jig and the technological parameters of the fine-grained material, 3 to 0 millimeters. During the test of OM24, jig considered the share of class size grade below 0.5 millimeter in the feed was 20%, which indicates the need to dislodging of this type of feed in order to ensure the correct flow of the process of jig-based separation process of such feed. Welcome, my name is Rafał Baron. I'm an employee of Mining Technology Institute, KOMAG. I will present the presentation of the definition of the concentration of rare earth elements at the Lower Silesian coal. The goal of this work is to analyze the quantity-based share of rare earth elements in the lens material. The subject of the test was the waste from the coal waste, mining waste from the already shut down coal mine of Lower Silesia coal mine, characterized by the high level of coal. The scope of work included the review of the state of knowledge on the rare earth elements, setting the future direction for the recovery of rare earth materials in Poland, starting the commercial cooperation, obtaining the material for samples, preparing the samples for laboratory analysis, conducting the laboratory analysis, defining the content of the rare earth elements in the sampled materials, and the verification of the results. The rare earth elements is a group of 17 elements with a strategic importance for the economy, for the growth of modern technologies. The demand for rare earth elements increases as the new technologies evolve. Against its name, in contrast to its name, those elements are not so rare, but the problem is their distribution, their disbursement. The rare earth elements are used in the production of the spark plugs, catalyst systems in the automotive industry, the displays of the hard disk in the electronics, fuselages, and the jet engines in aviation. The countries that have the largest resources of rare earth elements is the China, USA, Russia, India, and Australia. The worldwide extraction of rare earth metals is 739,000 tons. It is dominated to a large extent by China. Poland doesn't have its own resources of rare earth elements, so their potential sources include the hard coal waste, thermal waste, sand and gravels, deposits, used up electronic equipment, and waste, phosphate and gypsum waste. The presence of rare elements in coal includes the kaolinite, biotite, hornblende, and muscovite elements in content in the coal. Due to the strategic importance of the rare earth elements for the growth of the advanced technologies, and shown in the previous stages of the works, the share of the valuable elements in hard coal, the Institute of Mining Technology, KOMAG, began its research and development work efforts aimed at determining the content of rare earth elements in the mining waste. The mining waste that includes all waste from the process at the coal mine were collected manually on June 16, 2019 from 3 selected points. The subject of the test was the waste material from mining waste from the dump located next to Nova Ruda. As a result of the operations of the already shut down decommissioned coal mine, the dump has a large content of hard coal, which is confirmed by the numerous endogenic fires. The material reviewed was selected due to the share of the rare earth elements in hard coal obtained in the previous years. The 3831 coal type that is included in the dump that supplements the up to now analyzed coal that shows that this character of a material that has a low utilization possibilities in the economy. The first sample is the portion of the upper part of the sludge in the upper part. The sample 2 is the lowest part of the dump. Sample 3 is the material picked up from the vertical portion of the bottom part of the dump. Samples 1 and 2, that is the wet, moisturized sludge, was dried in the laboratory dryer. The sample 3 comes from the scarp from the cliff of the dump due to the high content of the granulation of individual graining, was subjected to the crushing in the laboratory crusher process, and subsequently with a sample separator, 3 representative samples were selected, half a kilogram each, that were then subjected to the analysis aimed at determining the concentration of valuable elements. The laboratory tests completed indicated the presence of the 15 rare earth elements, and the distribution of individual rare earth elements for the material samples tested is very similar. The largest concentration of the rare earth elements was in the P3 sample, 40.49 ppm of scandium. The total concentration of rare earth elements in the samples analyzed is as follows: P1 245.35 ppm, P2 235.5, P3 183.7 ppm. The samples that contain mainly coal sludge has a similar concentration of rare earth elements. The high concentration of rare earth elements in the P1 and P2 samples may be the result of rinsing out of those elements from the scarp, the cliff right next to it, where the intensification is 60-70 ppm lower. Based on the literature knowledge on rare earth elements, indicating a higher concentration of valuable elements in the finest grain size grades, the analysis was conducted in the 0.045 millimeters size grade. The analysis was conducted with using the set of seeds with a 2 millimeter mesh opening, 0.045 mesh. The process of classifying the gradation due to the fine grain characteristics of the material was performed in the wet environment using the shaking classifier. In contrast to the assumption, in the selected fine-grained portion, there was a decline of the concentration of rare earth elements and a smaller number of elements, down to 13. The concentration of elements in each sample is very similar. The maximum for scandium in the sample 1 of 18.68 ppm. The total concentration of rare earth elements in the samples tested for the size grade below 0.045 millimeter is as follows. The first sample 38.5 ppm, sample 2 34.3 ppm, sample 3 42.2 ppm. The intensification of valuable elements in the finest grain category size grade for mining waste is not so clear as in the full range. In the 0.35 millimeter, the largest scandium and cesium has the largest share, representing more than half of all the rare earth elements contained in the sample. As part of our works, the following stages were carried out. Starting preparation, resulting in obtaining the assumed materials for tests to determine the content of rare earth elements, preparation of materials for laboratory analysis, preparing the methodology for determining the concentration of valuable elements in the material with the use of mass spectrometer, determining the share of rare earth elements in the mining waste samples. The waste material analyzed that doesn't have economic use can be a medium of valuable elements in the size grade below 0.045 millimeter. We saw the significant decline of the shell versus the representative samples that contain the full gradation. Interpreting the results obtained, one should assume that the high concentration of valuable elements is including the higher granulation size grades. Therefore, one needs to perform a full analysis of the spectrum of size grades of samples obtained in order to determine the size grade that has the highest content of the valuable elements. The list of literature used. Thank you very much for your attention. Good morning, ladies and gentlemen. I'm an employee of the Institute of Mining Technology, KOMAG. I'm presenting the paper on the testing of the content of rare earth elements content in selected Polish natural aggregates. In the presentation, I'm presenting first the objective of the test conducted, introduction to the topic, appearance of rare earths in the natural environments, materials used for tests, the results, the test results, and the summary, the conclusions. The goal of the test related to the rare earth elements conducted by the KOMAG Mining Technology Institute is to identify a material that, subject to the appropriate processing, would constitute the source of obtaining such rare earth elements. The presentation includes the state of tests related to the natural aggregates. Rare earth elements is a group of elements that includes lanthanum and scandium elements. Those elements are enjoying a great interest that is growing in the world. This interest is related to a number of desirable properties of such elements. Those properties are used in many modern technologies. The rare earth elements are widespread elements in nature, but the main problem obtaining such elements is the fact that they appear in very low concentrations. The high concentration deposits happen very rarely. In nature, there is a lack of deposits of rare earth elements in pure form. Such elements are mostly shown in the form of minerals or compounds that are a result of ionization of the minerals. Currently, more than 250 minerals are known that include the rare earth element. Due to the very low concentration, very few of them can be exploited. Currently, the ones that are exploited are the deposits that contain mainly the following minerals: bastanites, monazite, xenotime, and the sorption and steel type minerals. Bastnasite is one of carbon fullerene. Its density is 4.9 to 5.2 grams per cubic centimeter paramagnetic, with a content of oxides of elements of 70 to 74%. It can be found in igneous rocks as pegmatite or granite, or in some metamorphosed rocks. Monazite belongs to the phosphoronitite group. Its density is between 4.98 to 5.43 grams per cubic centimeter. It's a paramagnetic type with a content of oxides of rare earth elements of 30 to 71%. It can be found in igneous or metamorphic rocks such as granite, pegmatite, and others, and in the brittle type of rocks after the weathering of igneous type rocks. Xenotime belongs also to these phosphorus types, and the density is 4.4 to 5.1 grams per cubic centimeter paramagnetic, with a content of the oxides of rare elements of 52 to 67%. Similar is monazite. It appears in nature. The sorption steel type of minerals refers to the deposits that are a result of the weathering of the rocks that contain the rare earth elements. Thanks to the small size of the grain of those minerals and the high surface, they can absorb large numbers of ions, rare earth ions. The content of oxides of rare earth elements reaches up to 60%. Simpler obtaining of rare earth elements, and in the case of earlier mentioned minerals, the deposits include 40 to 70% of steel type minerals, including halloysite, illite, kaolite, and others. Based on the previously presented data, the following materials were obtained: 2 plates of basalt and 1 plate of granite from the sites where the deposits are processed using the drilling type of works. For tests, the commercial products we use, such as the basalt aggregate 2 to 0 millimeters and the granite aggregate 2 to 0 millimeter. The halloysite is the result of a deposit that was the result of a weathering of the basalt rocks. It is exploited using the open pit method. The following material was used. Sand 1 comes from the sand and gravel deposit, which is exploited using the dredger. Subsequently, material goes through the rinsing, classification, and draining processes. The material used in the test is the result of classifier sieves, pulsator sieves with grain size below 2 millimeters. Sand 2 comes from the deposit, and the sand and gravel is the accompanying deposit. It comes straight from the deposit. The course of a test of the raw samples was as follows: drying of the materials obtained using the laboratory dryer, downsizing of the samples to 0.5 kilograms, mineralization of the samples using the microwave mineralizer, testing of the content of the rare earth elements using the mass spectrometry mass with the ionization in the compressed induced plasma ECM MS. Granite aggregate, the overall content is 43 ppm. That includes 3 individual elements: halloysite, scandium, and neoncene. The total is 190 for the basalt aggregate. It includes 8 elements. The overwhelming part is the light rare earth elements, 69.1%, and then the heavy rare earth elements, 29%, and the medium size, 6.6% rare earth elements. The basalt aggregate 2, the overall content of the rare earth elements is 112.5 ppm. That includes 7 individual elements. The overall proportion is light rare earth 54%, then the heavy ones 30.4%, and medium rare earth elements 14.6%. Halloysite. The overall content of rare earth elements is 146.2 ppm. That includes 15 individual elements. The overwhelming portion is the heavy rare earth elements, 52.3%, then the medium rare earth elements, 24.4%, and light rare earth elements, 22.6%. Sand 1, the overall content of rare earth elements is 122.5 ppm. That includes 15 elements. The overwhelming portion is the heavy rare 54.5%, and then the medium rare earth element 23.5%, and the light rare earth element 21.8%. Sand 2, overall content of rare earth elements is 14.8 ppm. That includes yttrium and cesium elements. On this graph, you can see the results of a test showing the individual rare earth elements that were detected in each sample. Next, the test of the content of rare earth elements in the fine-grained segments where we expect the concentration to be higher. The tests were as follows: reducing the size of the samples to 1 kilogram, sieving on the sieve with a mesh of 0.045 millimeter mineralization of analyzing of the samples, and testing of the content of rare elements in the samples obtained using the ICP-MS method. Basalt aggregate 1, the 0.045 to 0 millimeter size grade was 11.5%. The overall content of rare element increased, and it reached 374.3 ppm. That includes 15 individual elements. The overwhelming majority is the light, 80.6%. Then heavy rare earth elements is 10.9%. And the medium rare earth elements, that is 8.4%. The concentration in the tested size grade went up by 97% versus the entire sample. To a largest extent, the concentration of light rare earth elements went up by 170 ppm. To a lesser degree, the concentration of medium rare earth elements by 19 ppm, and the concentration of heavy rare earth elements went down by 5.1 ppm. Halloysite 0.045 to 0 millimeters was 34.8%. The overall content of rare earth elements went down, and it is 34.7 ppm, which includes 13 individual elements. The overwhelming portion is the heavy rare elements, this is 34.7%. Then the light rare earth elements, this is 39.4%, and the medium rare earth elements, this is 5.8%. The concentration of rare earth elements in the size grade tested went down versus the entire sample. Sand 1, the output of 0.045 to 0 millimeter was 0.65%. The overall content of rare earth elements went down, and it was 39.2 ppm. That includes 13 elements. The overwhelming portion is the heavy rare earth elements, 54.5%. Then medium rare earth elements, this is 23.6%, and light rare earth elements, this is 21.8%. The concentration of rare earth elements in the size grade tested went down versus the entire sample. On this graph, we are seeing the results for the size grade 0.045 to 0 millimeters, showing the individual rare earth elements that were detected in each sample. The results of tests completed clearly indicate the presence of rare earth elements in the tested materials with various concentrations and with various proportions. Tests of raw samples showed different proportions among the concentration of individual groups of rare earths. The granite and basalt samples show light rare elements prevailing over the others, whereas in case of halloysite and sands, the heavy rare earths are prevailing. Among the raw samples, the largest content was shown for the basalt aggregate 1, this is 190 ppm. The second highest result came from halloysite, this is 146.2 ppm, and the third one for sand 1, 122.5 ppm. Those raw materials were selected for the subsequent stage of test in the fine grain test. In the 0.045 to 0 millimeter size grade, the expected increase of rare earth element was shown only in the basalt sample from 190 to 374.3 ppm. The other samples, we identified size grades of 0.045 to 0 millimeter, showed the decline of the content of rare earth elements. The tests completed indicated the content of rare earth elements in the tested raw samples, the concentration is too low to carry out the extraction thereof with a profit. The identification of fine grain size grade 0.04 to 0 millimeter in case of basalt aggregate delivered an increase of concentration, which is also insufficient. Thank you very much for your attention, and please feel free to cooperate with us in the future. Welcome, ladies and gentlemen. My name is Piotr Matusiak. I'm the manager of Processing Systems Unit. The topic of the presentation is improvement of the quality of a commercial product by the use of a new KOMAG type jig concentrators. The decisive impact upon the quantity and quality parameters of the commercial products comes from the separation, namely the main process applied in the Polish processing plants. Separation of the hard coal in the jig concentrators represents a very important part of the process of the production of the commercial products, aimed at improving the quality of the material and achieving the parameters that are expected by the consumers of those products, quality parameters. As I mentioned in the beginning, the topic of today's presentation is the improvement of commercial products. This improvement was achieved through the modernization of the mechanical processing plant at the KOMAG Budryk. The project was completed in 2017. The first commissioning took place in 2019-2010. OM20. The modernized node includes 6 medium-sized grains jig concentrates OS18, 2 secondary cold as jigs OM20, and 14 bucket conveyors B1000. At the mechanical processing plant at the Budry coal mine, 6 medium-sized jigs were installed, separating in the size grades 80 to 0.5 mm, which was designed to the capacity of 250 tons per hour. 3 of those jigs separate hard coal of type 34, and the other 3 the hard coal of type 35. At the mechanical processing plant at Budry coal mine, the secondary separation system was applied. The design of a system for delivering feed to the secondary separation enables preparation only single jig. In the secondary coal dust jigs shown on this slide, the material that is separated after crushing of 12 to 0 mm with maximum capacity of up to 250 tons per hour. The rubber type sieves were applied in those jigs. In the jigs, both OS18 as OM20, the product, heavy product output of the product, in contrast to the system applied before. In these jigs, a new solution for controlling the pneumatic actuator faster were applied, which is less sensitive to the purity of the control air. On the next slide, we can see a sample picture of a coal dust jig OM20 installed in the processing unit of the Budry coal mine, and 2 medium-sized jigs OM18 and P. In the modernized systems for coal separation in the Budry coal mine, modern control systems were used of the KOGA type, but operator panel of such a system is presented on this slide. Among many features of the system, it also enables, among others, controlling the pulsating process, automatic adjustment of pickup of heavy products, control of the speed of the bucket conveyors, measurement and logging of the monitored parameters. This system enables also displaying the current content of ashes and calculating the content, the heating value of coal concentrate being produced. The next stage of our works was the completing of a test of efficiency of separation. The subject of the test was to determine the efficiency of a dry product separation process in the newly installed grain OS18 operating in parallel in the coal separating for coal type 34 and 35. On this table we can see the results of the balance of separation for the jig, sample jig OS18 for the type 4 coal. The share of the concentrate product was 29%, 5.5% was the intermediate product, the waste product was 65%. Also, the efficiency of a secondary separation process in the OMT jigs was also determined, for which the feed is the crushed outgrowth product based on the results of the laboratory analysis of the samples, industrial samples of the feed and the products of the separation process performed by the KOMAG Mining Technology Institute. This table shows the balance of products of separation of the jig. The concentrate product represents 16.24, 5% is the intermediate product, and the waste product is 78.71%. In the medium-sized jigs OS18, the perfection ratios were, the first stage was between 0.158 to 0.200 with a density of the separation of 1.636 to 1.999 grams per cubic centimeters. For the second stage of separation, it was between 0.172 to 0.186 thousandth part with a density of separation of 1.395 to 1.818 thousandth part of grams per cubic centimeter. The average value of imperfection ratio for jigs tested was 0.169. In the coal dust jig OM20, the imperfection ratio was achieved for the first stage 0.210 with a density of separation of 1.39 grams per cubic centimeter, and for the second stage 0.121 with a density of separation of 1.609 grams per cubic centimeter. The average value of the imperfection ratio for the jigs tested was 0.173. For the OM20 jig, with the number 4.707A, no imperfection for the second stage of separation was not determined due to the very small quantities of concentrated products. During the test, a very low in reference to the size of the jig OM20, the load of the feed in the range between 20 to 30 tons per hour, that corresponds to 8 to 12% of the rated load for those jigs designed for 250 tons per hour. This has a very adverse impact upon the process of separating the materials and the results of the separation due to the significant portion of a fine grain caused by the crushing of UP crusher of a feed before separation. A very low unit load of a jig of 1.5 tons per hour for 1 square meter of a jig. The waste product as well as the intermediate product were picked up in the form of a prepaid flow through the sieves through the flexible rubber sieves. The improvement of the quality of the carbon concentrate with the coal concentrate with set technological parameters, including the increased efficiency, was achieved among others by modernizing the system for delivering feed to the jig, including the dislodging sieves, installing the control system of the Golgaster type, automating the media control, modifying the system for pickup of the heavy product, and modernizing of the auxiliary system, including the sieves and conveyors. The modernization works for the processing plant of Budry coal mine were conducted in cooperation with the user, which resulted in developing innovative technological and design solutions. Thank you very much for your attention, and please let's start cooperation in the future. Good morning, ladies and gentlemen. I'd like to present to you the paper which is related to the use of sieves built by the Progress Eco company in Kielce in the process of modernizing the separation plant of PG Silesia, coal mine Silesia. Interviewed the authors of the materials are Piotr Pesowicz, Klaudia Bończyk, and Jerzy Weiss, and Dr. Bogusław, who is the main chief engineer at the coal separation unit at PG Silesia. The process system for coal separation at Silesia coal mine is relatively simple. It includes the initial classification station, then the second stage classification. The product of second stage classification is separated using the DISA gravitational settler, and after the third stage of classification, the material is routed to the cyclones with the dense media settler, and the final products that are subjected to drainage. The large size, coarse products and medium size are shown on this table, whereas the coal dust products are shown in this table. The modernization of processing of separation unit was started in 2015, completed 2017, and in the technological system, the most modern sieves were used that were on purpose designed and tailored to the technological coal separation system applied in PG Silesia. For the pre-initial classification, the control WK1 sieve was mounted, which you can see on this drawing. The sieve is equipped with, the screen is equipped with is characterized by high durability and large clearance. The next, for initial classification, two screens, double deck PWP2 were mounted, equipped with a braided, stretched sieves, characterized by a large clearance equipped. They are equipped with harp-type sieves made of wire, stainless wire. The lower deck of the sieve is characterized by the high efficiency of sifting and is done in such a way so that the material is not gluing, so to force the self-cleaning process. The next stage is the initial classification. The initial classification is performed by two separately mounted screens, PWP1, equipped with braided stretched sieves. There are 4 screens installed in 2 lines, 2 screen devices each. The view of those screening machines as they were mounted in the cold separation plant you can see on this picture, but now shown. Here you can see the harp-type sieves, what they look like. The next screening machines, the screening process, the next stage is the screening of the bottom product from the previous classification stage. The bottom product is screened on the PWP1 screening machine, armed with longitudinally stretched string sieves with a mesh size 6 millimeters. The next classification is the classification of this separation product. Coal, so the concentrate is routed to the draining screening machine PWP1. The screening machine is equipped with slotted sieves mounted in the propylene system. The screening the machine you can see on this drawing. However, the deck of sieves on this screening machine is shown on the next slide. The material from the draining screening machine is directed to the control screening machine. It is equipped with a modular rubber sieves with a mesh size 100 millimeters. For improving the cleaning of the deck, there is a draining screening machine slotted with a protection profile. It's mounted behind it, downstream. The next stage is here on the next slide. You can see the next stage. Ladies and gentlemen, we have completed the second session of our conference, during which you had a chance to listen to 5 very interesting presentations on the improving the efficiency of separating the mineral raw materials. Thank you very much for your activity. If you have questions sent, we will try to give you promptly answers to all of them and send them to the authors of those questions. At this point in time, we'd like to invite you to take part in the third session, where we will also listen to 3 very important and interesting presentations. Ladies and gentlemen, our conference has very interesting and very holistic approach, and here we are moving very fluently from strictly technical topics to the future, more future-oriented topics, where we'll be presenting the outlook for the mining industry. And the third session will be on the topic of the transformation of the post-mining land. Let us remind you that right after the end of the third session, a discussion panel will be held on the future of the separation system, processing systems. During this panel, which will start at 12 o'clock, we'll have an opportunity to listen to a very eminent guest. We'll have Mr. Artur Dyczko, the Vice President of the Management Board of JWSA, Mr. Piotr Nowak, the Chief Engineer for Processing at Bogdanka Company, Mr. Grzegorz, Director for Processing at Tauron Wydobycie S.A., Mr. Kamil Korzepa, the Director of the Medical Production Unit at Carbo Montka S.A., and Mr. Adam Mura, the CEO of Węglowa Limited Liability Company, and Mr. Piotr Myszkowski, the CEO of a Pro Industry Limited Liability Company. Please feel free to listen to our debate. Thank you for your attention.
Warto rozwijać w województwie śląskim.
But developed in the Silesia region, it is indicated among others the construction industry, logistics and recultivation. Those industries ensure relatively good wages. They are similar in terms of competence and skills to the mining sector, and are in line with regional specializations of Silesia region. The challenge will also include
Here I am in the heart of our Nord product range. Nord Drive Systems manufactures a very large range of drive technology products. Gear units, electric motors, electronic drive technology and industrial gear units. The overall portfolio is a unique modular system from which individual solutions can be created for our customers. Our most well-known drive systems consist of a motor and a gear unit, the geared motor. Our drive systems can also be extended by frequency inverters. Here we have a decentralized solution, also available as control cabinet version. The most complex systems can be seen here. they are used for higher torques or powers. Nord has therefore developed the Max Drive Industrial Gear Unit series, including various integrable components. The almost infinite combinations allow for a drive that perfectly matches the requirements. Let me show you an example. This drive system, consisting of industrial gear unit, electric motor and fluid coupling, is mounted on a swing base. You can also choose an IEC motor attachment, use B5, B14 flanges on the output side, mount a modular external backstop installation, and choose many more product options. Here is another example, a typical application, a belt conveyor drive. Consisting of electric motor, coupling solution, industrial gear unit with axial fan for achieving maximum thermal limit powers, mounted on a swing base. Realized from our modular system. Here is a typical application, a mixer drive, consisting of agitator flange, max drive industrial gear unit, IEC adapter for fitting a Nord electric motor, and a decentralized frequency inverter from Nord, vertically mounted from the modular system. And we also have the perfect drive system for you.
This is the 18th edition of the International Fair of Mining, combining 350 exhibitors from 12 countries, 26,000 square meters of space. Please join us on the stage.
Województwo śląskie oferuje wiele rozwiązań dla biznesu. Natomiast Międzynarodowe Targi Katowice 2021 to wyjątkowe wydarzenie. Dlaczego warto się tu spotkać?
19. edycja Międzynarodowych Targów Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021 już przed nami. To jedno z największych wydarzeń w Europie i trzecie na świecie. Spotkamy się już między 7 a 10 września 2021 w Polsce, w Katowicach, w Międzynarodowym Centrum Kongresowym oraz na placu przed Spodkiem.
Nadchodząca edycja targów Katowice 2021 została wzbogacona o Międzynarodowe Targi Energetyczne B2 Energy Poland.
Jako organizatorzy Przygotowaliśmy dla Państwa ponad 60 000 m² powierzchni targowej.
Katowice jako serce województwa śląskiego to miasto otwarte na biznes i przyjazne inwestorom. Znajdujące się w nim Międzynarodowe Centrum Kongresowe to wyjątkowy obiekt, który został wyróżniony jako jeden z najlepszych kompleksów do organizacji konferencji, kongresów oraz targów w Polsce.
Oprócz naszych targów, Międzynarodowe Centrum Kongresowe gości również 5. Polski Kongres Górniczy, Europejski Kongres Gospodarczy i wiele innych.
Dla przemysłu istotna jest branża energetyczna i elektryczna, która podczas targów B2Energy Katowice 21 ma doskonałą przestrzeń do prezentowania innowacyjnych urządzeń i technologii. Targi o charakterze międzynarodowym to świetna okazja do podjęcia współpracy z międzynarodowymi koncernami energetycznymi i odbiorcami końcowymi.
W odległości 100 km 3 duże lotniska: Katowice, Kraków, Ostrawa. Dojedziemy do Katowic szybkimi trasami i autostradami, jak również znajdziemy tutaj szeroką bazę noclegową, a tereny wystawiennicze okalają parkingi. Podczas ostatniej edycji targów gościliśmy ponad 350 wystawców i odwiedziło nas 30 000 zwiedzających, w tym delegacja z całego świata.
Jako organizatorzy wspólnie słuchamy i dopasowujemy się, by stworzyć idealny klimat spotkań do rozmów o kierunku rozwoju tej strategicznej branży. Rozmowy toczą się na płaszczyźnie krajowej i międzynarodowej. Organizator targów gości delegacje zagraniczne dzięki współpracy z miastem Katowice i Izbą Gospodarczą.
Tych wszystkich, którzy się jeszcze nie zdecydowali, zapraszamy na Międzynarodowe Targi Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021
oraz Międzynarodowe Targi Energetyczne B2Energy Poland.
Spotkajmy się na targach od 7 do 10 września 2021. Katowice. Miasto przyjazne biznesowi.
Sytuacja na rynku pracy w sektorze górniczym jest i będzie bardzo zmienna. Dzieje się tak z przyczyn niezależnych zarówno od pracodawcy, jak i pracowników. Zmiany, którym górnictwo podlega, wymagają od osób w nim zatrudnionych lub poszukujących tam pracy nieustającego podnoszenia lub nabywania nowych kwalifikacji.
Spółka JSW Szkolenie i Górnictwo opracowała pilotażowy projekt górniczej aktywizacji zawodowej. Dzięki temu dajemy szansę górnikom, jak również mieszkańcom Śląska utrzymania miejsc pracy w górnictwie. Szansą jest edukacja, czyli podniesienie lub nabywanie nowych kwalifikacji zawodowych w górnictwie.
Projekt Górnicza Aktywizacja Zawodowa GAZ, finansowany w całości ze środków Europejskiego Funduszu Społecznego, przeznaczony jest dla osób, mieszkańców województwa śląskiego, pracowników bądź byłych pracowników jednostek organizacyjnych spółek węglowych lub przedsiębiorstw z nimi kooperujących. Projekt przeznaczony jest dla osób zagrożonych zwolnieniem, przewidzianych do zwolnienia bądź już zwolnionych. Projekt pozwala podnieść swoje kompetencje oraz kwalifikacje zawodowe, zyskać nowe atuty niezbędne na współczesnym, dynamicznie zmieniającym się rynku pracy.
Projekt Górnicza Aktywizacja Zawodowa GAZ to nie tylko kursy zawodowe służące podnoszeniu lub zmianie kwalifikacji. Spółka JSW Szkolenie i Górnictwo wspólnie z Akademią Górniczo-Hutniczą z Krakowa przygotowały też studia podyplomowe.
Jednym z ważniejszych elementów projektu Górnicza Aktywacja Zawodowa są studia podyplomowe, które będą prowadzone w Akademii Górniczo-Hutniczej w Krakowie. Uważam, że projekt jest ważny i potrzebny społecznie, dlatego zachęcam do udziału w nim.
Szczegóły na stronie www.jswsig.pl. Projekt Górnicza Aktywizacja Zawodowa GAZ. Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW, Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
In production industries, there is a rising demand for reliable systems to monitor plant condition. Nord has recognized this need and produces predictive maintenance solutions to increase availability and make it easier to plan service and maintenance. Nord modular industrial gear units are available in 11 sizes with powers of up to 4,000 kilowatts and torques of up to 250 kilonewton meters. In our application test area, we demonstrate the opportunities of digitalization for gear unit operation and maintenance. On a test bed, operating states are simulated by two interconnected industrial gear units. The gear units are equipped with sensors for speed measurement, temperature monitoring, and intelligent vibration analysis. Among other things, this shows how unscheduled downtimes can be avoided, availability of plant and machinery can be increased, and their value can be preserved. Sensors record the necessary basic data for the Nord cloud solution. For example, they monitor vibration or temperature. Integration of other sensors, such as oil level monitoring, is also possible. Via the frequency inverter, the data are available for power and torque analysis. The data are processed by the frequency inverter with an integrated PLC or are sent directly to a gateway. Via the gateway, the data are then sent to the cloud so that they are available for evaluation and analysis from anywhere in the world. To avoid unnecessary data traffic, the local intelligence ensures that data are only sent if their values have changed. The logged and analyzed data are available in a web interface. During a learning phase, the reference state is first recorded. Information from databases for the individual components is used for this. The operating state is compared with the reference state in real time using intelligent algorithms. This enables precise conclusions about the state of the monitored gear unit components, such as gears and bearings, in each stage. Warnings are automatically sent to the cloud if abnormalities are detected. This enables optimum planning of servicing and ensures the availability of the plant. This means that a deterioration can be detected before damage is caused. The application test area also demonstrates the added value of modern data analysis, even in plants without predictive maintenance. Alarm thresholds for faults can be set up to shut down the plant in case of an alarm. Detailed analysis of the data enables in-depth examination of the damage symptoms. The frequency analysis enables conclusions about the part which is causing the measurement change. Therefore, faults such as bearing damage or gear wear can be identified and localized. Predictive maintenance provides great added value for plant operators. Availability is increased. Maintenance costs are reduced and servicing can be planned more efficiently.
Ladies and gentlemen, the transition of the Silesia region, Silesia voivodeship, understood as a change of its profile, economic profile, has been taking place underway for 30 years now. The current point in time can be called its turning point. Among the alternative activities that in particular are developing in the Silesia region instead of mining sector jobs include, among others, construction industry, processing, energy industry, and recultivation. These sectors provide relatively good wages. The specifics of the skills and competences are similar to those for the mining sector, are in line with the regional specialty of Silesia region, Silesia voivodeship. The challenge will also be to ensure the prospects for jobs outside of the mining sector for the young workers. The precondition for the just transition is the development of attractive support tools for everyone, taking into account their individual preferences and predispositions. The green economy is the priority area for the Silesia region because of the largest potential to take advantage of in the economy. This is more than 51,000 entities according to the REGON registered data. The new strategy, industrial strategy of the European economy, European Union envisages the fact that Europe needs an industry that will become more ecological and digital, and at the same time will remain to be competitive on the global market, the global scale. OECD is estimating that within 20 years, almost 20% of the current jobs in Poland will be, to a large degree of probability, liquidated and replaced with machines. The next 32% of jobs will be subjected to a significant modernization due to the digitization. It means more than 3 million automated and more than 5 million transformed jobs. The conducting of the optimization activities and modernization activities in the production processes allows for maintaining the required level of standards, quality standards and market standards, norms, and allows for the further expansion, development of the company, and increases the ability of the company to introduce organizational, innovative, technological and technical changes. The subject matter production process can gain new capabilities, new options, new opportunities, particularly in terms of improving the comfort of operation, diagnostics, improving the level of safety work, WHS work, precision, efficiency, broad spectrum of abilities for remote control, including the reporting of the production effects. An important element of growth potential for the region is the involvement in the research and development activities that provides the basis for developing and implementing innovations. In 2020, in Silesia region, there were 642 research units that constituted almost 11% of such units in Poland, nationwide. Despite the high research and development potential over the last 3 years in the Silesia region, the decline of the funds allocated to research has been declining. So it's necessary to increase the amounts, the funds allocated to the research and development as well as innovation activities in our region. A good example in this area could be the Sense VR project, which is financed by the National Research and Development Center. It is being implemented in partnership by JSW Innovations, the Chief Mining Institute, and the JSW Szkolenie and Górnictwo Mining and Education unit subsidiary. The VR applications will be implemented for the needs of training needs of JSW Capital Group personnel, as well as the Polish mining group, PGG. They will also be implemented a number of enterprises from the medium and small size enterprises. The job activity, professional activity ratio indicator in Silesia region has been for years at one of the lowest levels nationwide, and this is standing at close to 53%. The region has been for years characterized by the large share of people working in the manufacturing industry is more than 38%. What needs attention is the category of those working in the services sector. Those people accounted for almost 59% of the total number of people employed in our region. The social problems, economic problems, and space-related, land use-related problems after restructuring of the coal mining sector that has been underway since the 1990s can be felt even today, up to today. The largest headcount reduction in the mining sector took place in 1998-2003 timeframe, when 29 coal mines were put into liquidation. The Silesia region is grappling with the demographic problems and the employment of young people, with large diversification in the situation in the labor market in the sub-region, as well as with monoculture. The essence of the education, for professional education, especially for the youth, is identifying the skills in the individual jobs of vocational education, creating conditions for gaining additional skills, professional skills, as well as additional vocational professional authorizations or market qualifications that are functioning within the integrated system of skills and qualifications. Flexible response of professional educational system for the needs of the labor market, its openness to the opening throughout one's life, and the educational mobility and professional mobility, both of graduates as well as employees, is the basis for the professional development of a human being, taking into account the fact that this process takes between 40 and 50 years. The digital competences of an employee are closely related with the knowledge and skills leading to the effective use of the available information and resources. The growth, the development of the modern sectors of the economy, as well as the ICT technologies, creates special conditions for the functioning of a human being in the contemporary social and economic processes. The number of information sources going up, and as well as the pace of changes in terms of rules for information processing. This means that the employees are obligated to continuously update their knowledge of working positions, taking advantage of the available information resources, applying the legal regulations as well as the ethical rules. Under the term digital competence, there is a very broad set of skills that are the prerequisites for the efficient and conscious use of new technologies and active participation in the life of the information society. The key development challenges for the growth challenges for the Silesia region are focused around the human being, environment and economy. The immigration of young people going outside the region means that in the forecast until 2050 the number of inhabitants of the Silesia region will go down by almost 20%. The next is the improvement of the condition of the natural environment. It should be concentrated on two main issues. The first one, the gradual reducing of gas and dust pollution, and the second one, the other one, is incentives, introduction of incentives for the businessmen that are planning to recultivate the degraded post-industrial areas, land. The next challenge is the increase of share of the Silesian economy in the creation of Poland's GDP, as well as the improvement of GDP growth rate per capita per inhabitant in the subsequent years. Again, besides, improve support for intelligent specializations in the region, energy, medicine, healthcare, green environment, green economy, telecommunications, ICT, and the emerging industries constitute the main development challenges for the Silesia region. Thank you very much for your attention. All those interested in the projects under the name the mining job activization are warmly, cordially invited to contact us. Thank you very much. Good morning, ladies and gentlemen. My name is Celem at JSW. I'm responsible for foreign relations, including for the EU regulations, and this is the topic I'd like to cover today in my presentation: how the European regulatory environment impacts the operations of our company and somewhat the entire sector. Please, to start with an introduction regarding the regulatory environment, the European Commission announced new EU strategies, so the European Green Governance, Green Deal. The number of initiatives will be announced in the near future, and also the financial instruments that are to help achieve the objectives set. Additionally, the sustainable financing issue in this thing is also getting more and more important. I also elaborate on that later. The main goal of the European Green Deal is achieving the climate neutrality by 2050. Protection for the human life, plants and animals by reducing pollution, supporting initiatives aimed at clear worldwide leadership with respect to the clean products, and ensuring the transition is in a just and inclusive manner. The proposed actions will be focused on investments in the environment-friendly technologies, supporting the industrial innovation, especially in the key areas such as the production of clean hydrogen, expansion of fuel cells and alternative fuels, energy storage, CCU and CCS technologies, implementing cleaner, cheaper and more healthy public and private transportation systems, as well as reducing the emissions in the energy sector. In November 2018, the Commission presented the long-term strategic vision of well-prospering, modern, competitive and climate-neutral economy for the economy until 2050. The vision of the climate-neutral future includes all the areas of the policy and is in line with the Paris Accord, which is to maintain the increase of the temperature well below 2 centigrades. The European Commission proposed in March 2020 the European climate law that would impose on the EU countries a legal obligation to achieve climate neutrality by 2050. This is the consequence of a decision of the European Council of December 2019 about approving the climate neutrality objective. The Commission also made a proposal to introduce a border tax carbon border adjustment mechanism. The varying level of reduction activities leads to the risk of transferring the emissions generating production to the countries where there are no curbs on the emissions of greenhouse gases. So therefore the proposal to adjust the prices on the borders taking into account the CO2 emissions. The legislative proposal will be presented by the Commission in the second half of 2021. One of the most important areas of the operation is the new industrial strategy, which is aimed at maintaining the leadership position of Europe in the manufacturing industry. Therefore, it's focused on 3 projects that include the maintaining the competitiveness of the Polish manufacturing industry, European manufacturing industry worldwide, and ensuring the equal treatment, equal playing field on the global level, achieving the climate neutrality in Europe by 2050, and developing the digital future of the European Union. Manufacturing industry, especially the energy-consuming industries, will have to work to reduce its carbon footprint as well as to accelerate the transition towards the clean technological solutions. For the manufacturing industry to fulfill all these expectations and be as much as possible clean, sustainable, innovative, the need for the clean accessibility of the clean energy and raw materials will be the key, and to achieve that the following activities will be required. In the transition of the manufacturing industry, there must be a migration from the dependence of fossil fuels to being independent from the thermal energy-related commodities that are important for have a demand. The demand is to increase by 2050, especially for the critical commodities, raw materials that are necessary in the mobility sector, batteries, renewable energy sources, defense and aviation. Without a major dependence on to reduce the dependence on the import, the Commission developed a plan of activities that includes a part of critical raw materials aiming at cooperating in ensuring the security of the supply. The Commission announced the European Alliance for Raw Materials for Commodities. The next area related to the implementation of the EU climate neutrality objective is the implementation of a circular economy assumptions which allow for maximizing the use of the available resources and its byproduct, the recycling of waste, as well as innovative use. Such actions will allow for reducing the waste problem through the well-functioning secondary byproducts market. Also will make it possible to make Europe independent of the outside the European Union importers, and consumers will be able to take decisions buying products with a longer expiry date. This will be supported by the so-called taxonomies of regulation on the sustainable financing. This regulation implements the general rules of taxonomy defining what investment projects are friendly for the economy, for the environment, and which are not. The goal of taxonomy is to ensure comparability, customer-facing choice of two products that declare the achieving of a sustainable plan to a varying degree. Will not go back to the taxonomy that the goals were set according to the same rules. The economic operations is qualified as a sustainable if it meets 4 reasons and contributes to one of the 4 of the 6 goals, environmental goals. Additionally, according to the requirements, according to the regulation, the non-financials will be obligated to report the share of the capex and turnover related to the environmentally sustainable operations. It's all aimed at achieving the climate goals. Targets. Another important issue from the point of view of enterprise is the regulation on the disclosure of information related to the sustainable development in the financial services sector, which imposes the obligations of reporting the indicators, among others carbon footprint, consumption of energy, consumption of water and the waste, the generation of waste, indicators of the proportion in the wages for women and women, protection for whistleblowers, taking care of human rights respect, and counteracting corruption and bribery. Now, at that point, there is work underway on revising the directive on the non-financial reporting, and the draft of a new document will be published in April 2021. It will include the description of developing standards. The legislative work will last probably to the end of this year, and the first reporting according to the new standards will take place in 2024, will be applicable to the data for 2023. The implementation of climate neutrality target, the European Commission is intending to support through dedicated funds. The Innovations Funds is to be one of the main sources of financing for the innovation technologies with respect to reducing the emissions in the energy-intensive industries, use and capture of carbon dioxide and its storage, technology for generating electricity from renewable sources, as well as energy storage. The financing for the implementation of the projects will be gained from various revenue of the European trading system, EU ETS. The innovations funds will be supplied with about 10 billion euro from the auction of 250 million of EU allowances in 2020-2030 timeframe. This fund will provide support for up to 60% of additional costs related to the innovative technology, as well as the additional support in terms of the operating expenses for maximum 10 years. The applications will be received on a regular basis until 2030 every year. The second important source of financing is to be a Just Transition Fund that will be used to provide support for the EU regions dependent upon the coal in transition and mitigating its negative consequences. As part of the support of the transition towards the climate neutral economy, the European Union wants to also use the existing Coal and Steel Research and Development Fund. Currently, this program is subject to a revision which is aimed at guarantees adjustment, alignment with European Green Deal objectives. With respect to the fund, this fund will be focused on the implementation, development of CO2 and methane capture technology, capture and storage, improving the skills of coal mine employees, use of extraction waste such as ashes and recultivation of dumps, protection of ground sources and purifying water treatment facilities. The second half of the year, first recruitment process will take place, and the budget of the project is about 40 billion euro. The European Union is to become a first climate-neutral continent by year 2050. However, the other leading economies of the world are also moving in that direction. For instance, India, that is the third largest producer of greenhouse gases in the world and are responsible for 7% of the global emissions, have an economy powered in 70% with coal energy. The 23%. Another 33% gigawatts are currently being built. On the other hand, there is a support growing for the pro-climate event, planning to increase the 35% increase of renewable energies to up to 27 gigawatts, and in reducing the emissions by 1/3 versus 2005. Another more Indian corporations that didn't rely on the energy giant or Tata giant announced climate neutrality objectives, and setting the objectives for climate neutrality for 2050 was a prestigious challenge for China, that are planning only 2060 to become climate neutral. That would strengthen the position of India's international position and pressure on the countries that did not announce their targets yet, such as Russia and Australia, for instance. Russia has a strategy for the low-emission development until 2050. However, they haven't announced their climate neutrality target yet. So far, such goals were announced by Japan, South Korea, and the US. Thank you very much for your attention. In case of any questions, please stay in touch. Thank you very much, and good morning. My name is Katarzyna Pruciak-Karasek. I am the head of the team for the European Commissions at JSW. During this presentation, I'd like to present to you the assumptions of the European Green Deal and the accompanying documents, including in particular the climate policy, and present to you the activities in this area performed by JSW. European Green Deal and the accompanying documents, challenges and aspirations of JSW. The most important objective for European Green Deal, namely the new economic strategy for the development of the European Union, presented in the communication of December 2019, is the profound pro-ecological transition of the economy to allow, at the latest by 2050, to reduce the emissions of greenhouse gases to zero net in Europe. A certain quantity of greenhouse gases will still go to the atmosphere, but they must be offset by the consumption by the ecosystems or technical devices. The document contains the preliminary plan that covers the initiatives in a number of closely tied to one another areas: climate policy, environmental policy, energy policy, transportation policy, and agricultural policy, as well as the sustainable financing area. The implementation of the vision for the European Green Deal was defined based on the earlier communication, Pure Planet Forever, and Clean Planet Forever, and it's based on 7 strategic elements: energy efficiency, renewable energy sources for the total decarbonization of energy, pure mobility, clean mobility, competitive industry and the circular economy, the development of infrastructure and the mutual connections between countries, the development of bioeconomy and the CO2 absorbers, and the capture and storage of carbon. As part of implementation of the assumptions of the European Green Deal, as a first document in March 2020, the draft of the European Climate Law was presented, which was amended in September same year due to the agreement reached by the member states of a new intermediate GHG gases emissions by 2020, the new target. This draft assumes achieving zero net emissions by 2050, introduction of GHG gases emissions by 55% by 2030 versus the level of 1990. That's 15 percentage points higher than the target agreed in 2014. Implementation of those goals is to be carried out through investments in environmentally friendly economy, supporting industrial innovations, introducing cleaner, healthier and forms of transportation, reducing emissions in the energy sector, providing higher independence of buildings energy, and cooperation with wealth analysis of covering by wages of other high emission sectors, and the introduction of a border tax as a new way to protect sectors against losing competitiveness and the carbon leakage. And the following steps of the review was proposed regarding the EU regulations to the climate, including the regulation on the European Union emissions trading system, the regulation on the common reduction effort, joint reduction effort, regulation on the forestry and land, the so-called LULUCF, directive on the energy efficiency, directive on the renewable energy sources, and the standards for CO2 emissions for cars. As it was already mentioned before, the implementation of the European Green Deal assumptions includes the initiatives in the closely interconnected domains, which is carried out through the publishing of successive documents that specify in more detail the European Green Deal. Apart from climate law, so far, among others, the European Industrial Strategy was published, which is to aim at increasing the global competitiveness of the EU industry and provide its resilience and autonomy, and the plan of circular economy actions aimed at the sustainable use of resources. Priority will also be the limiting and the reuse of the materials before they are subject to recycling. Also, the minimum requirements preventing the introduction to the European markets of products that are harmful for the environment. The strategy related to the integration of energy systems and the hydrogen strategy indicate the main direction of the energy transition, which assumes the growth of renewable energy sources and increases the share in electricity production to 50% in 2030 and 84% in 2050. Furthermore, the electrification of the heating industry and the transportation and promotion of clean fuels such as biogas and green hydrogen. EU methane reduction, emissions reduction includes also actions in the sectors of agriculture, and which are responsible for 95% of the methane emissions related to the human activities in the world. In June 2019, the European Commission, as part of the actions aimed at sustainable financing, published new, non-binding as of today, guidelines regarding the reporting by the enterprises as part of non-financial reporting of information related to climate. The guidelines were based on the recommendation of a task group with respect to the disclosure of financial information related to climate, the so-called DCFD group that was set up by the Financial Stability Council. The guidelines are aimed to address to the companies that are subject to disclosing the non-financial information, namely the large units, public interest entities, stock market listed companies, banks, investment funds with the average annual headcount of more than 500 persons and fulfilling certain financial criteria. The new guidelines include the disclosures on the climate issues related to 4 topics: corporate governance, strategy, risk management, and metrics and objectives. As part of those 4 areas, what the companies are expected to do includes, among other, identification and evaluation of the risk and opportunities related to the climate change with respect to the production, operations, and supply chain, defining the role of management in evaluating the risks and opportunities climate and supervision, oversight of the management order over them, and the scenarios, including physical risks such as the increase of periods of heat and droughts and extreme weather developments, and the risk of a so-called transition towards the low-emission economy. And here we can enumerate technological, market, and regulatory risks. Furthermore, the assessment of the impact of opportunities and chances for the strategies and financial plans, and the business model analysis of resilience of the model and business strategy to the climate changes, taking into account various scenarios under various time frames. Furthermore, the reporting of greenhouse gas emissions, of the carbon footprint of the entire organization, defined in the scopes 1, 2, and 3, and defining the ultimate values related to the climate as part of adopted climate policy by the company. So the metrics and the climate goals, that targets that are included in the business projects and decisions. JSW, in its updated last year strategy of the group for the 2020-2030 timeframe, defined the main directions of the project activities in these areas of counteracting the climate change. We can mention here the reduction of the carbon footprint of the organization by maximizing the use of methane and coking gas for cogeneration, electricity generation, management of the post-industrial land, rational waste and water management, taking into account the protection of the surface and groundwaters, and byproducts used for infrastructural products as a part of circular economy involvement, seeking for the low-emission solution, technological solution, process and legal solutions, as well as implementation of TCFD requirements of reporting on the climate change and developing based on them of the climate policy of the group. One should also mention that the coking coal for the third time was listed as a critical commodity by the European commodities, that the risk of its shortage is higher than in case of other commodities. Since 2020, the companies more and more often are deciding to define their carbon footprint. That's becoming repeatedly a part of its CSR strategy. The TCFD guidelines regarding the climate change reporting, although not mandatory as of today, have accelerated the process of the European Green Deal. Requirements of plans of financing sustainable economic development indicate that the carbon footprint will be an important part of defining the impact of the enterprise on the climate, and in the future it will become a standard. Carbon footprint defines the total greenhouse gas emissions to the atmosphere as a result of human operations by a person, organization, event, or a product. Its measure is the so-called equivalent CO2 tone that including the emissions of all greenhouse gas emissions on one scale. Balancing and looking at the emissions and looking at the supply chain and the manufacturing process enables to define to what stage of production and what emissions are highest, and take a decision on what actions will be taken to reduce it. The JSW, in respect to calculating the carbon footprint of the entire JSW capital group for the two main products, coal and coking coal, has been conducting since 2018. Since 2018, we've been reporting the carbon footprint in our organization and the actions taken aimed at reducing it in our report on operations and in the integrated report. The biggest source of greenhouse gas emissions stemming from the operations of JSW is the methane removed for security reasons from the coal mines headings. This is 90% of the total carbon footprint. The key to reducing its emissions is the inclusion and the use it for generation of electricity. Around 86 million cubic meters of methane is utilized, with about 1.70 tons converted into the CO2 equivalent. In Budryk and Knurów-Szczygłowice coal mines, we've been implementing the economic use of methane project, which is aimed at increasing the recovery of own in-house energy and reducing the carbon footprint by another 1.5 million tons of CO2 equivalent by year 2025. In order to have a consistent approach to the climate change actions, in 2020, as part of the constant committee, CSR committee, standing committee of CR, the team working on the JSW climate policy in accordance with the TCFD guidelines on reporting the climate change. From the very beginning, from 2018, we've been involved in the auctions for the CO2 units organized by the National Forest as part of the project, and 14,000 units of CO2 we purchased for 150,000. each unit is responsible corresponding to 1 ton of CO2 emitted into the atmosphere. The project is aimed at increasing the quantity of CO2 captured by the forests, mainly the trees and the soil, and the reduction of emissions from the wetlands. State forests are performing additional steps as part of its forestry management, increasing the second floor of the floors and increasing the surface and the natural recoveries, regrowth, and activities aimed at preventing the natural destruction of the soil. Going to this project through the purchase of CO2 units, we are supporting the project that's in our project in the Kobiut authority called Modernization of the Education Path in the bison-friendly part. It's a separate part that is purpose is for education and tourist purpose, where you can reach out to a bison. As part of our cooperation in the first stage of the project, we are able to adapt the route to make it available for disabled persons. Also, the plan is to develop the green labyrinth, a 5-meter educational tunnel where the models of animals living underground will be mounted, and providing the moorlands model and the flower meadow. We realize that in view of the challenges that we're bringing in place in front of us, we are facing a lot of challenges where the balancing of the carbon footprint is one of the most difficult ones. With the aid of the JC Innovations subsidiary, we are involved in a number of activities aimed at research and development, aimed at providing the transition to the low emission economy. The most important one includes the production project of separating hydrogen from the coking coal, the technology for reducing the CO2, or recovery of methane from the ventilation exhausts. To sum up, the most important challenges regarding the environment protection and the climate protection that the JSW faces in the near future, and based on the need to implement the assumptions of the European Green Deal and the accompanying documents, as well as the planned obligations due to the reporting, non-financial reporting for the stock market companies, including the TCFD guidelines, taxonomy, and the new guidelines for the issuers, stock market issuers regarding to the GSR guidelines on the disclosure of information regarding to the sustainable development in the low emission technologies. We can include the developing the climate policy, defining the reduction targets long term up to 2050.
Obliczenie śladu węglowego.
Calculating the carbon footprint of organization in 3 scopes in the entire value chain, implementing the guidelines of TCFD regarding the reporting on climate change, fulfillment of the requirements of regulation, among others, on taxonomy of the SFDR regulation, and obtaining the financing for the research and development innovations projects underway and planned that will enable us to migrate to the low emission technologies.
Dziękuję Państwu za uwagę.
Thank you very much for your attention and the time you devoted to listening to my presentation. Ladies and gentlemen, we have completed the 3rd session already, where we were able, among others, to listen to the very interesting presentations on the transformation on the post-mining land. Those presentations clearly showed us to the challenges that the mining sector is facing in terms of the prospects and changes, and any problems that also will definitely be emerging. Ladies and gentlemen, that was both the transformation regarding the social, legal, practical aspects, as well as any challenges that we are facing. In just a moment, we'll have session number 4, that includes the discussion panel, during which our guests will be able to present their opinions regarding the future of the processing systems. This panel will be conducted by Mr. Professor Dariusz Prostański, the director of Mining Technology Institute, KOMAG. And right after the discussion panel, we'll have a last session today called Green mining. During this session, you will have a chance to listen to 5 interesting presentations where we'll be covering the topics related to methane in the aspect of reducing the methane emissions. We'll cover the circular economy topic, and finally we will listen to a presentation regarding the utilization of a post-mining land in a view of a just transition of the mining sector. So please listen to our debate and to our panel and the next session. Thank you.
wszyscy panowie są, jedynie kogo nie ma, to pana prezesa. Dzień dobry Państwu, ponownie witam serdecznie.
Ladies and gentlemen, again, welcome to the discussion panel, during which we'll be discussing the future of processing plants in the Polish mining sector, coking coal sector. Therefore, I invited the representatives of both, from the mining part, from the mining sector, as well as the representatives representing the producers, manufacturers of processing machines. Please let me start by introducing our guests. Let's start with the one who is not present yet, Mr. President Dyczko, who is not available yet. He'll be a bit late. Unfortunately, his duties kept him away for a moment. On my left-hand side, we have Mr. Piotr Myszkowski, Pro Industry, the CEO. Later on, further on, we have representatives of the coal mines. Excuse me, Mr. Piotr Nowak from LW Bogdanka, the head of the processing unit there, Mr. Director Nowak, and Mr. Director Grzegorz Pawłaszek from from Tauron Wydobycie, well known for many years in the Polish mining sector. Further on we have Adam Mura, the CEO of a company called Wrębowa Limited Liability Company, and Mr. Kamil Korzepa, representing Carbo Automatica Company. As you can see, we have a group that is capable of saying some interesting things about the Polish processing industry. Gentlemen, I would be very much interested in discussing the condition of our processing and its capabilities in the Polish coal mines, how the processing plants look today, what should be the future, what we should be aiming to achieve, and I think we should start the discussion with the coal producers. If you allow me, the first question I'd like to ask, first of all, to the Director Nowak, representing the Lublin coal mining company, due to the fact that we are dealing there with quite heavily centralized processing plant, a very modern solution, and as a matter of fact I'd like to find out whether this unit, this plant meets all your expectations, whether you've done this, you build this plant according to your wishes, and all those wishes have been accommodated, and do you need to do anything else out there? Please, Director. Welcome, ladies and gentlemen. I have a great pleasure that in spite of the difficult times we are able to meet and discuss the industry-related issues. I think it's very important during these days, these times. What can I say? In 2014, we completed quite a long investment process of expanding the entire processing unit plant from 1,200 per hour to 2,400 tons per hour capacity. The very investment process, of course, difficult and complicated. The design project difficult and complicated, but we were able to complete it successfully. Of course, during the commissioning, the startup of the plant, during the tests, certain, I would say, infancy diseases came up that didn't allow us in the very beginning, in the early stages, to achieve what we wanted. But due to the fact that what the Director mentioned, we have a centralized plant, we have a centralized thinking about the people, about the fact that we as an employer, we need to provide as much from ourselves to make our contribution as big as possible. So that's what I how to do it. So therefore, we practically began the implementation at a high level, high quality level, at the level that we are satisfied with was 1 year from commissioning. That's when it happened. So we started dealing with eliminating the bottlenecks. We're eliminating those bottlenecks, we're finding them first, then try to discuss them and solve all the problems. Now I can say that we are at quite a high level of, to a large degree we've achieved what we wanted, but we are not over-satisfied. We don't want to stop there. Let me say what's our target. My goal is, what I see here, is continuous seeking to implement digitization, digitize and automate those processes. It's not so that as someone sometimes you tell your employees that the digitization you want to eliminate the employee, the human being, to make it cheaper. My thinking is totally in an opposite way. I see it as a help for our employees, because we will not eliminate the people involved in the process, technological process. We must be frank here, but we can make it easier for the job, easier for them. I'd like to mention our one recent plan, solution that we are planning is. We are planning the entire hydro classification system, which is for both units, let's call it old and new one, the heart of it, the core. We are planning to fully automate it. In order to do that, we have to provide the metering for it, or the measurements for it, but we will be satisfied with. But the amount of data that we need for that is so large that we need to develop ourselves, create ourselves the database to be able to manage the database, in order that later, when we have such a high variability of the output of the feed that our miners, friends provide to us, to be able to manage the system in an automatic manner, but of course with the oversight of an employee, because as I said, it's not the point to eliminate the people from the production cycle, but to provide assistance to them. So I think that's all I'd like to say for now. Let me just add in this part of my present statement that results this year that we're achieving this in this plant are deviating far from what was the design perimeter. So we have more capabilities, what we were aiming to achieve in our designs. It's hard to say where is the limit for this unit, but I think that should make us just happy, not worry. So that's what I'd like to finish my statement and hand over the floor to my colleagues. Thank you very much. As you can see, even if you have a modern plant, so there's always something to do about it. A bit more complicated situation the Tauron group is dealing with, Tauron mining, where they have 3 plants and 3 in different forms, at a different level of modernization. As we know, the Sobieski coal mine has the largest capex, Janina a bit less, and Brzeszcze even less. But maybe the director Pawłaszek would like to present to us the situation, how the situation will be reflected in the near future. I'm talking about the condition of those units, please, if I could get an answer from. Good afternoon, ladies and gentlemen. Well, Tauron mining, that is, includes the Sobieski, Janina and Brzeszcze coal mines. Its process of modernizing the plants were commenced in the 90s. Maybe for some of the people this is going way back, but even at that time, Tauron mining introduced modern solutions. At that time, we were using the devices and machines, partly 4-in-1s in the first stage. We are using the German technologies, we are using the mineral jigs. Now it's changed in such a way that we are using our excellent solutions, developed among others by KOMAG, with respect to the jig-type solutions. One must say that the coals extracted by Tauron is thermal coal and heating purposes coal, but however they are applying a high degree of separation among the thermal coal, Polish coal mines. I think the separation process is the most advanced there. Ladies and gentlemen, due to the fact that we are separating the coal dust fractions, which is fine grains, which is about 80% of the coal extracted. So daily at such a plant, you need to make wet, separate about 10,000 tons of output. You can imagine how complicated is the water and sludge circulation system to make this flow a circular flow. Of course, we've been handling it for years. We are dealing with it. Of course, we don't have such a modern solutions as Bogdanka has, but we do realize that the future of the Polish coal is the production of dedicated fuels. Those will be doing best, that will be able to flexibly adjust their product to the requirements and needs of the consumers. So these are the tasks that we have ahead of us. Therefore, our processing plants are very flexible. They require continuous changes and upgrades. The dedicated fuels is not only just those fuels that will be used by the fifth generation furnaces, but we also use as dedicated fuels fuel dedicated or delivered to specific coal-fired units in our corporation. Of course, it's not very easy to meet all the challenges, but this is the goal for the forthcoming years. This is what we set for ourselves, and I think we are able to accomplish it. One may say that the technologies applied meet our expectations. They ensure, they provide the quantities with respect to the separation of the coal that we have, and practically take into account the decarbonization process. It will be progressing. We are not planning any major capex in this regard. Thank you very much. This is true that unfortunately the decarbonization process is stopping a lot of our plans for the future that we had a few years back as producers and manufacturers, as we as KOMAG Institute also have to modify our plans for the future. If you're talking about the manufacturers, producers, they also may face in the near future a different situation that they have now. Not necessarily it would be a worse situation, but to start with, I'd like to start with Director Kamil Korzepa. How is your offering fulfilling on one hand the needs of the coal mines, because as we know, the companies that manufacture products for coal mines practically may meet all their needs, but Karba Automatka itself group, how broad is this offering versus the needs of the coal mines? And as a matter of fact, what are your how the coal mines, how big are the orders coming from, purchase orders coming from the coal mines versus your expectations? So defining the needs of coal mines versus your expectations, if you could maybe respond to that in a few words. Welcome, Mr. Gentlemen. We think as a company that the contemporary processing plants are aiming at improving the quality of the coal produced, and at the same time reducing the cost of its production. To achieve that, investments are required in modernizing the processing units and in new technologies. As Karba Automatka Group, we are trying to supply comprehensive automation visualization systems of individual machines, as well as the technological line concepts. An example could be the recently installed the fine grain granulation on the Blosiach-Miały coal mine installation. It's the installation that's been operating at 40 tons per hour capacity, and the granulate has a 12 to 14,000 kilojoules per kilogram calorific value. Each of the devices that is part of that installation is fully automated. This allows us to receive the signals at the main control room, from where the entire production process of this granulate is being monitored and managed. An important advantage of the system, and generally speaking, the automation, is the fact that what Piotr mentioned, the reduction of headcount. Not necessarily the point is to reduce, but to help. But it allows to manage the production cycle with a minimum number of people and eliminating the individual errors. It's very important because it's all problems related to installation may lead to losses. Another important aspect of the installation is the fact that one can utilize this fine grain coal, the coal dust, which is problematic. Plus also with financial benefits due to the sales of granulate. So it's also an important direction for other processing units to think over. Another issue that we are focusing on is any type of software CNMS installed among others at Knurów coal mine. The goal is to improve the quality of work by planning the overhauls, the maintenance of the machines and devices, and replacement of fast-wearing parts, planning the procurement. They create the history of the use of the operation of a machine from the commissioning, and allow for the correct operation of the machine in line with the manufacturer's guidelines, and I think to a large degree allow for eliminating failures and outages of the machines. Important elements and the automation systems are all types of scales and pro-sampling and machines at the loading, because they enable the assuring the continuity of the loading process, while the same providing the continuous quality analysis of the coal in accordance with the standards required. Another very important direction, very good direction, interesting direction is also the defeminization stations that use the cogeneration systems that, as of today, allows also for using this electricity to power the processing plants, as well as buildings and infrastructure related thereto. Generally speaking, I think that the comprehensive approach with a broad offering that includes automation and visualization of the processes is the future of the processing units, and will definitely improve their operations, improve the efficiency. And I think that one needs to cooperate, work with the processing units, processing sites, the personnel, as well as the research institutes such as KOMAG, because this is definitely the direction that will allow for creating the new devices, new machineries, will help out for improving the efficiency of those devices. Thank you very much. Thank you very much also for mentioning the fact that KOMAG is dealing with such solutions, such as the solutions for the processing units, because that's true. We are offering almost complete or practically complete processing sites, processing plants, not in any imaginable configuration, but as we look through the processing plants and the cooperation with our partners, a number of such solutions come from our company, our institute, our drawing boards. So I'm very happy to see that you're looking in a modern way at the processing plants, because one should remember that the care and about the manufacturer and the institutions that are designing those plants at the very plants on an ongoing basis for years is very important, especially for the coal mines and the full functionality of those units, as well as for the manufacturers to have markets available and a happy customer. If we talk about the manufacturers, another representative of those manufacturers is the Węglowa company, and Mr. Adam Mura, the CEO, definitely can tell us now what the situation is of plans of a company versus the demand from the coal mines, whether you have some interesting investment project lately. Thank you very much. Good afternoon, ladies and gentlemen. Answering that question, of course, we are looking for outside the mining market for markets, but the basic market is the mining sector market. Around 70% of our capacity is allocated to the mining sector. What we are offering to the coal mines, we are offering three directions that we are implementing, namely, as it was mentioned by Director Pawłaszek here, we are manufacturing the installations for the dedicated products of the coal mines. Recently, we can boast implementation of EcoP at the Farowice coal mine, where practically the effect of that investment project, the capex, were recovered by the coal mine within 2 months. After 2 months of the operation of installation, we received the funds, and we are still waiting as well for the funds to be paid, to be transferred for the implementation of the task. So a very strong financial effect, and the dedicated product. It's an installation based on the crusher to cylinder crusher that we are manufacturing together with our Czech partner. Currently, I was there last week, and the scales indicated 947,627 tons. This year we will reach 1 million of EcoP output on that installation and the Kławowice coal mine. It took place within 3 years. The second direction that we just completed lately on the Pniówek coal mine is the replacement of the existing installation, including the improvement of its efficiency, improving the quality and improving the energy intensity, so less consumption of energy. We replaced with the aid of the KOMAG company that designed the jig. We replaced the 8 jigs at the Pniówek coal mine, 8 bucket elevators that are used to pick up the product from those jigs. We replaced the 4 also sieves and the entire infrastructure around this, also civil works around this installation. And one should know that our plants built at the same time roughly require a lot of outlays, not only on upgrading the devices, but also on replacing the steel structures and also such, let's say, modernization of the overhaul of the existing structures. The third direction of our activities include the modernizations of existing systems. And here we can give an example, the modernization of powering 5 filter presses at Knurów coal mine, where we eliminated the entire compressed air installation using the Abel pump, but the spinning pumps fill up the press with large feed and low pressure, and subsequently the Abla pump takes over with low feed and high pressure, supplements this press. So the technological process effect was very remarkable. The adjustments were improved, and with non-uniform feed, we have this dry input also due to the improvement of resultant product obtained. There's no problem getting the product off the plate and also filling up the carriages due to the low moisture content. There are no problems with transportation. Also, we improved the financial effect by way of reducing the power consumption. The pumps were limited with 75 kilowatt power rating, that was replaced by 30 kW Abla pumps. So even and to choke pumps, and even based on this balancing of power consumption, you can see that they have a big financial implication and improvement. Our partner was here, the Prime Industry company, but also at Pniówek coal mine did such an installation. According to their data, the annual financial effect in terms of reducing the consumption of power is 200,000 per year, 1,000 PLN per annum. These are the effects, elements that we see in the mining sector, but outside the mining sector, we continue to look for our place. It's easier for us, probably, in terms of selling such devices as crushers and conveyors, because these are the devices that are needed and required by all available markets. Currently, we are doing bucket conveyors for the Tarnów Azoty plant, also screw-type conveyors for the Exide company. So the transportation devices market is quite broad, and here we are doing quite well. Of course, we are penetrating the forgotten by us market because due to the full utilization in the mining sector is the market of aggregates and waste treatment plants. This is also mining, Mr. President. Yes, that's true. But we also see the hope in such a market, waste landfill sites, where due to the new regulation and the limited number of such waste sites, landfill sites, there is a need for more detailed segregation, and we are able to complete for this market segment for those waste disposal site, waste landfill sites. We used the mining technology, the jig equipment technology of a company that we are working with in the mining sector together with a KOMAG company, a system for separating or segregating for the waste landfill sites. If you have nothing against, I can show a movie, a video on the work of operation of such those devices at the waste landfill site to illustrate how our mining jig is operating at the waste landfill site. If you allow, we can display this video after we complete the debate as an example of a summary. It's an interesting solution. Maybe you can tell us later in the next iteration of questions about the mode of operation, what is the difference between that and the mining implementation. But if you allow me, I would like to move to my neighbor to my left side, Mr. Piotr Myszkowski from the Pro-Industrial Company. As we've heard, it's also participating in. Also, thank you very much for the answer. Of course, also is frequently involved in works and projects at different coal mines, and this, Mr. President, is specializing in presenting business case, economic analysis of various solutions. At Knurów or Newvec, we can always see very clear presentations of economic financial benefits and effects. You mentioned the jig concentrations, and Mr. President also is always saying that the hydrocyclones with heavy media, heavy liquid are better. He was able to implement at PG Silesia those hydrocyclones. Whether you can convince us whether they are better, please say a few words. And why those hydrocyclones are not used by other Polish coal mines, and whether it's a simple replacement, we kick out the jig and we insert the hydrocyclone, we have a solution. Thank you. Few words. That's true. The hydrocyclones with the heavy media, heavy liquid is my area of specialty that I've been dealing with for more than a dozen years, and with a pure conscience, with the deepest conviction, I'm promoting this solution in at the Polish coal mines. And here, the professor really touched upon a very important element. Why they are not more widespread. They use not more widespread in Poland. One could think that there is nothing against it, because on one hand, no contraindications, because these devices enable producing more coal from the same quantity of raw coal, primary coal, with a high separation efficiency rate. On the other hand, we are getting a material of much higher quality than, for instance, the one coming out of jigs. I mean here the quality of the concentrant, namely the coal, but also the quality of waste, the mineral fraction, which is, from that point of view, not pure because it is contaminated with coal. So the point is to make it a secondary reuse raw material, not to not to make it a waste. And this is the action we are taking here. Why the hydrocyclones with heavy media or heavy liquid? Worldwide, Poland seems to be an exception because worldwide, majority of cases, majority of the coal processing units, hydrocyclones, heavy media cyclones are being used because they enable increasing the revenue of the processing plant by selling a larger quantity of coal. But on the other hand, they are much simpler in the technological process because one or two hydrocyclones are enough to screening machines, a few pumps, the magnetite recuperator, several tanks, pipings, and this is the system that works much better when you separate coal. Reducing the operational personnel and the operating of heavy media hydrocyclones doesn't have to be highly qualified as in case of jigs. Very simple automation because the quality of the product we are just adjusting control lever, just the density of a separation. That's what we said, is you don't have to do anything else, you do it very quickly. And it's very easy, thanks to that, to change the parameters of the products that we are achieving. One of my predecessors mentioned that you need to produce for the market. That's of course true, but you need to have an option to change the parameters of the product that we are producing in a very simple manner. As I mentioned, the majority, overwhelming majority, more than 90% of all the coal processing units size worldwide is based on the heavy media, heavy liquid hydrocyclones, and not in Poland. And the very good question is why? Well, I've been thinking about this for a long time, and as a matter of fact, and I think the Polish mining industry is, and any mining sector is conservative, namely any novelty must be accepted. However, I have an impression that sometimes this conservative approach means that there is resistance against accepting changes, because change is not so simple that we cut out the jig and we insert the heavy media hydrocyclone. If we want to move to that technology, we must be thinking about building a new plant or a new technological line that we will try to insert into the new old building. But this technological configuration based on the jigs is not fit for heavy media hydrocyclones. Therefore, we are talking about large capex here. Although we have done and we are doing such simulations for the Budry coal mine, the Knurów coal mine, and it turns out that the profit, the gain from selling a larger quantity of coal, thanks to the use of heavy media hydrocyclones, will be recovered within several months or maybe 2 years. So therefore, these are not it's not the level of expenses that you should resist it. I think there's a bit of a mentality problem of the people. So the acceptance of change, because it's very difficult to change the attitude of the operators who know very well how to operate the old system and try to convince them that the new one is much better. Although, coming back to the original question of the professor, how do I see the current times and what could be its impact upon our actions? I think it's a big opportunity for us, because the situation that we are facing now with coal and politics regarding coal forces the coal mines to have a different approach. And this is an opportunity for us. Kind of referring to Mr. Mura, CEO Mura, about 200,000 of savings on the coal mine comes from both power supply consumption savings and less consumption of the fast-wearing parts, because the pumps in the fast-wearing parts, this is the biggest item, cost item in the spin-type pumps. That's all. Just to provide some comfort, Mr. President Tyszko is not with us yet, but JSW is the producer of mainly the strategic commodity being the coking coal, so future-wise it has the biggest period of operations in front of it, potentially, but it's not a secret that a lot of processing plants require a lot of capex, starting with better separation of individual size grades and the separation, and up to the drying and getting the product that is dry enough to be commercially acceptable. But JSW has been struggling with that all the time, modernizing, implementing, but maybe there is some room here for heavy media, hydro cyclones that, and I'd like to wish that President here to achieve it. But the current situation, that's one thing, but we know that we have a just transition in front of us, and we know that EU is pressing to stop producing thermal coal. As far as coking coal, no one is yet dealing with that because it's a strategic commodity, but Tauron Group and Lubelski Węgiel are the producers of currently only the thermal coal, the steam coal, or heating coal. So in the same sequence as before, I'd like to pose a question first to Mr. Piotr Nowak, the Director. What will you do in the near future, 10, 15, 5? Who will you sell the coal to? Well, before I answer this question, Professor, I'd like to express Lut's opinion. I agree with Mr. Grzegorz 100% that the dedicated coal markets is the future, and I agree also with the fact that because of that the flexibility of the processing units must be higher and higher. Also agree with Mr. Kamil that we need to implement automatic solutions to a larger energy. I agree also with Mr. Adam. Mr. Adam is applying the mining technologies in the niche, I would say, sectors as of now, but also uses for that those mining technologies. And I agree also with President Mieszkowski, but President Mieszkowski mentioned the precision. So in fact, this is what the point is. I have this loose thought that if everyone wanted to build a processing plant that would make it the most efficient, most effective processing site or plant possible that we can imagine. So thank you for this part of the conversation. What's in the future? What's in store in the future? Well, as we know, Bogdanka, at the end of last year, announced its strategy for the coming years, and we're supposed to verify the assumptions adopted in 2018 by updating it to up to 2030 with an outlook until 2040. As it was mentioned here, we know that coking coal is a strategic fuel, and since Bogdanka has a license for extracting coal from Ostrów field K6, K7, so we are intending to take advantage of the opportunity that we have. The plan is that by 2025 we will continue to operate in thermal coal only at the roughly 9 million to 9.5 million tons per annum. However, starting from 2026 and in the subsequent years, we're also planning to extract the coking coal. We want, in our new strategy, that the number of products offered, we want to be extended by adding this coking coal, and our plan is to make it 1.9 to up to 2 million starting from 2026. We're talking about the 36 type because this is the one that we have in the deposits that I mentioned. However, what is it? How does it compare to our plan? This is now an honor to be paid to our predecessors. The type of a license made certain assumptions, knowing regarding the coking coal at the concept area before the design stage, and certain solutions we practically have in place at our site. Of course, we are analyzing the technical aspects more in detail to be able to say whether we will have to add something or change something, but whether it will happen in fact, it's way too early, but the analysis is underway, and Belbelski Węgiel sees that's an opportunity that starting from 2026 to start producing the 34 type coal as a strategic commodity. That's all from me. Let me hand over the floor. Thank you very much. I would say the same thing, but I will ask the same question, Mr. Director from the Tauron Wydobycie Group. So please, we have the same problem, but probably not the same coal for the future at least. What is the strategy and expectations for the future of Tauron mining in this area? In terms of Tauron mining, I think that we should maintain our capability to operate those electricity generation capabilities with respect to coal-fired units that Tauron has. But it's difficult to speak about any expansion in that area because there's still a number of coal mines that will be looking for the place on the market. Our future is to create, as I mentioned before, the possibility for the flexible development of coal blends. This is the direction that we'll be aiming for. We think that the technologies are very good. If what Mr. Myszkowski meant was the difficult separation of fine grains in the jigs, so in our systems we dealt with that, but applying fairly high heart, which separates very effectively the tiniest fractions, the finest fraction, which in case of use for thermal purposes are definitely sufficient. Of course, one can look for ways for more selective separating. However, in case when the coal is very diversified, it's not a monolith of any type. They are difficult to separate, so the use of a super technology doesn't generate the expected effects, but it'll either go into the concentrate or in the intermediate product or waste. This is the separation, the split. In all areas we have the tri-product separation that enables the maximum utilization of coal substance that's included in the output. So our future is invariably related to our capital group, and one would like us to have market share for the latest installations for the individual, for the households. Because it's not, unfortunately, possible to eliminate from the single-family houses our coal. Although it's true the decarbonization is a one-way path, we can go faster, slower, but we are not able to lose it. Mr. Pawłaszek is an optimist, it's very good, but I think sooner or later, if we are not able to use this coal, we'll do something with coal. Either we'll do gasification or hydrogen or another product. We do it for a bit better times, cheaper technologies, and such institutes as KOMAG, KPW, GIG, GIG would like to contribute to that process. Time is pressing us a bit, but I don't, God forbid, stop the discussion now. One may say that Mr. Ditchko is helping us in shortening the time through his absence, but I would like our producers, our manufacturers to ask what future they see of Mr. Mura already told us that you're rerouting as the company Węglowa to other areas. We are interested in those waste sites, landfill sites. At least I'm personally the use of jigs, but Carbo-Automatica, or is it intending to locate its processing devices at other types of facilities, such as the production of gravel, sand, quarries that also generate fine solids or other minerals, mines, excavations, or you want to retool your production profile. Maybe you're thinking about the countries in the east of Europe, Asia, or Africa, where still there is a strong demand for the processing systems, and the level of processing the aggregates is very low and done in a very primitive way, I would say. Please, Mr. Professor, I think to start with, starting with the foreign setups, definitely our applications can be used there because the material is quite similar. However, as of today, COVID is a big problem to start cooperation. Nevertheless, we have applications. Recently, we managed to deliver last year a screening machine to Morocco for initial classification for phosphorite. However, as of today, as a group, we think that the basis for growth is looking for markets and responding to the market needs. What Professor mentioned, apart from other markets such as energy industry, chemical industry, waste management, Mr. Mura mentioned a very important direction. Recently we focused on aggregate excavation sites, gravel sites and sand sites, because since we have coal separation systems such as crushers, screening machines and the shaking screens and versus conveyors, so we're trying to redesign those devices and adapt it to the markets of aggregates, sand and gravel sites. Our application, we focused semi-mobile, I would say, compact structures, designs that allowed us to adapt our solutions to those markets. All those devices have a full visualization and automation system, which is definitely needed in those sites, because these are open pit sites where you have very few personnel, and investors are trying to start the entire plant with a single push button that you can see everything in the central control room, but one person oversees the operations of the entire production. We do that, we know that. An example could be recently acquired, and we are finishing implementation, the contract for the separation crushing line at the Dolomites mine, 250,000 250 tons per hour capacity, where through automation, starting with the unloading of the output through the processes of crushing, sorting, up to the prisming with conveyors of ready-made commercial products. We are completing this line. We are at the stage of commissioning. The line is fully automated, is equipped with a control room, and the entire line is a single person is overseeing the entire production process. I think from the future perspective is definitely a desired direction. The other markets, similar as gravel and sand excavation sites, as of today, we are focusing, for instance, on designing and adopting the device for the preliminary draining of gravel, a draining kind of wheel, uptake wheel. I think it's a basic equipment for the gravel excavation sites. We have delivered a few shaking screens and devices for classification to the sand sites, excavations, and also conveyors, also common in those installations, are also within our offering. Important such systems for the metering of bearings and any central lubrication systems that are very important for such type of installations, because we know very well that the proper bearings lubrication increases their longevity, their life cycle, and enables a longer operation of the machine, as well as monitoring of the bearing systems allows for the initial diagnosis and of initial degradation of a bearing, and it enables a faster replacement of failures and outages due to those failures. And I think the long-term experiences in the mining sector that we all have is a good foundation to go outside the mining markets, because we do have the machines, as I mentioned. The question is to adjust those machines and adapt them to market needs. So the mining sector-related companies, this is a good direction to follow. But coming back to what the professor mentioned about the mining market and what Mr. Piotr Nowak, director, said, we can set up a number of plans and modernize them, but we need capex for that. But we know very well that recently there's been a problem with that. And this is why our expansion, looking for new markets, an attempt to go to the new market in order to utilize the capacity that we have available. Thank you very much. I will ask a question to President Mieszkowski here. If not mining, then what? And what mining? And how to do it in the mining sector in the future? Well, we doing very well also outside the mining sector. Well, mining, we understand it very broadly, also the Polish copper mining company, and aggregates are available there. So chemical industry, energy sector, steel making sector, that's also the sector we're trying to be present in, but coming back to the mining sector and coal mining, and because I think this is the most important for us persons gathered here, the most important topic. Short term, of course, definitely all those actions such as modernization, machinery fleet replacement, as we supply the pumps for feeding the filter presses. We are partnered with a company that produces granulates, and also on the Bolor-Ośmiały coal mine we were involved. Definitely, yes, these are very important things, but the future, in my opinion, should, besides that, once we make a decision to do a large modernization, this modernization should not just bring us only the increase of productivity, capacity, also should generate the measurable economic financial benefit. Of course, taking such a decision is not easy, but it seems to me that only economics and free market and what's happening worldwide will force such actions. What's happening worldwide? Well, we know that because we are in contact with the worldwide manufacturers of processing machines, and the technological diagram or structure of the coal mine is a bit different in Poland because we have crushing about to 50 millimeters. Between 50 and 1 we have hydrocyclones, heavy media hydrocyclones, because this is the range that they are very good at operating in. Between 1 millimeter below, now the trend is that the flotation, and here we're talking about mainly the coking coal, flotation is minus 0.25, in Poland it's below 0.5 millimeter. It's clear that the flotation is very costly process, and if we limit the number of feed streams to the flotation and reduce the size of the grain, that flotation works much better. Therefore, the range from 1 to 0.25 is covered by such hydrokinetic separators of various designs that we also have in our offering, and practically the entire flow of the materials in a processing plant is closed. This quality is much better. Purity of the mineral fraction is difficult to call at this point a waste, is such that you can use it for other purposes. Therefore, the coal mine is becoming a no-waste plant, and I think this is the future that we also are facing in Poland. Clean mining, irrespective of everything, if we produce clean products, definitely something we'll be able to do with that something. But modernization, I think, in my opinion, of the coal processing plants should be based on the expected economic benefit, profits and losses, the size of the capex and the payback time, payback period. If we are able to foresee what will be the EU's policy, whether it will not change in the other direction. As I recently read, the Britons are interested in building a coking coal mine in order to be independent of imports. They are being only stopped by the social pressure against starting this investment project. This year in winter, Germany launched a coal-fired unit. Why the greenest country in Europe did that? So therefore, let us do our thing and let's try to lobby our mining sector, but let's try to make it more and more friendly, at least for those users of home boilers with low emissions are really a problem, and the fuel available for such user is of very low quality. We have Mr. President Adam Mura from Węglowa. I'd like to ask here whether would you like to show us this jig on the waste side, because it's an interesting example. Waste sites, we have lots of those. We can segregate them into various light, heavy, fine fractions and reuse them. Well, thank you very much, Mr. Professor. As you mentioned, our place on the market outside the mining sector I described before, I'd like to supplement this my statement showing you a short video, so I'll try to put it on. I don't know if I manage. It looks like something's working there. So please have a look.
Jeszcze tutaj dźwięk włączę.
Maybe the sound. So the entire process separating various types of waste, yes, of garbage, yes, glass, metals, yes. Well, we cannot hear the audio. So maybe I will put it on. And please comment, maybe. So here, of course, the subtitles. Here we can see this light fraction, draining of a light fraction. Here's the draining of a heavy fraction. Here in the bucket elevator, of course, this is rocks, glass, and this type of products that are marketable and are used in other processes in the construction industry, for instance, for this. And the other part, the light one, is placed on the way side, but the effect is that about 60% of the feed of that product is recovered and reduces the volume of the waste side. Let us see how this is. What it looks like on the prisms, what quantities we are talking about. This is the heavy product. Rock, glass, rubble that will be applied and is marketable and can be reused, whereas this light fraction stays at the waste side. This is practically all, that's the entire process. So thank you very much for your attention. Thank you very much as well, Mr. President. I hope our discussion today made a creative contribution and something interesting, and thanks to that we'll be able to come up with some reflections where we are heading, both with the mining sector and with the coal processing. We know that it's usually the least noticeable part of the processes by the coal mine. The extraction is always at the forefront, and processing is usually the very end. Examples of modernization, some not always, examples of modernization we can see the pure product, clean product, and the reusable material instead of waste is very important. Ladies and gentlemen, thank you very much to all the participants, the directors, the presidents for participating in this debate. I'm very glad, I'm very happy that you all accepted this invitation. I do hope that we'll meet again in a more personal way in the next conference in the stationary mode, but only due to company-related reasons we'll not be able to meet in person but online. But I hope this group could attend our conference physically, and after a year or we can have a look and see if we took a step forward, talking about society, our industry, and our reality, not about specific solutions. So thank you very much to everyone for taking part in the debate, and I'd like to take the advantage to announce the next session that we have today, that will be related to the green mining. And, ladies and gentlemen, during this session, we'll be talking about the strategy for reducing methane, generally about the methane-related problem and ventilation, and methane derived from coal mines, but also about implementing the circular economy at JSW company, as well as about the geodesic measurements regarding the revitalization, recultivation of the post-mining land, recultivation, revitalization. What's next? Professor Begańska will tell us about that. These topics have already been covered partly, but these are the topics that will be appearing more and more often, and there will be money for that to implement such solutions, because this is what our environment calls for, not only the reality, but we also try to take advantage of our resources the best possible way, even if they are treated today as ordinary waste. Thank you very much, ladies and gentlemen, and please watch the next session, and I wish you pleasant viewing. Thank you very much. Good afternoon. My name is Artur Badylak. I have a pleasure to be head of Office for Metallization in the office of the JSW. The competence of the office includes the broad and understood topic of reduction of methane emissions to the atmosphere and the utilization of methane. The topic of title of the session is the zero emission mining. So methane is the biggest challenge besides any discussion. How we can achieve that, if it's possible at all, I'd like to invite you to a presentation during which I will discuss briefly the strategy, European Union strategy for methane and the operations of JSW with regard to reducing the methane emissions to the atmosphere. The title of the presentation: the activities of JSW in the aspect of a European strategy for reducing methane emissions. Well, it's an important topic. The topic is a hot topic now. On the 14th of October 2000, the reduction of emissions of methane in European. Many people say that even during that decade, the methane could be covered by the European trading system. Even this year, some press releases say that that having the current methane emissions the JSW emits, that would be a real tragedy. Methane is a strong greenhouse gas, only second to the carbon dioxide in terms of a general contribution to the climate change. The GWP, the indicator of geographical population for methane, is 28% over 100 years time frame. The European Plenary assumes the reduction by at least 55% by 2030 as compared to 1990. That will require accelerated efforts in order to reduce the methane emissions. Current activities are targeted reporting, monitoring. This is the first step to control the anthropological emissions of methane. The announced October strategy, one could make a reference between December 22nd, January 26th, the action plans and feedback could be sent. Public consultation began starting from February 5th about the reduction of methane emissions until May 1st. Filled questionnaires can be sent regarding that topic. Already this year, the proposals are to be announced in the European Union law, but are to reduce reducing the methane emissions in the mining sector. The MRV topics are being discussed. So measuring, reporting and verifications for all the sources related to the energy production, LDR, detecting and repair of leakage, and implementing the 2.0 standard for monitoring, reporting and verification of data also for the coal sector, which is difficult to agree with that. The specifics of the oil and gas sector for which this standard was developed is different from the coal mining. According to information published in the methane strategy of the European Union, methane is responsible for 5% of the worldwide methane emissions, namely around 17 million tons. In the European Union, the largest source of anthropogenic emissions of methane is agriculture, 40 to 53%, then waste, 20-26%, and the energy sector responsible for 19 to 30% of methane emissions. According to the above, one can assume that the coal sector of the European Union is responsible for 0.19% of the worldwide methane emissions. Why there is so much pressure on reducing methane by the energy sector? The general opinion is that the general sector is easiest and fastest to achieve effects. If we're talking about the emissions of methane at the JSW Commons, it's very metered and reported, measured in detail. The total quantity in 2020 that was emitted was more than 362 million of cubic meters. The main way to reduce the atmosphere methane is the demethanization of rock mass. We covered more than 140 million of cubic meters of methane with that. The efficiency was about 40% then. It's a very high rate. Worldwide, the efficiency of 30-35% of demethanization is accepted. The concentration in this system is about 50%. So it's a gas that can successfully be used to generate electricity. In 2020, they used 86 million tons of methane for business purposes. Remembering what is the emissions of methane from the JSW coal mines, if you cover methane by the EU ETS system, as I mentioned, that would be a disaster. Assuming the 28 methane and current prices for CO2 emissions and the euro exchange rate for the cost of emission rights after subtracting the methane that was utilized would be more than 1 billion PLN. On this graph you can see it is shown in the dotted line that how over the last years the CO2 emission allowances prices went up. Last year it was 22 euro per ton. Today it is 42 euro. The forecasts say that the prices will be going up, and in 2 or 3 years it may reach even 70 euro per ton level. At JSW, we do realize very well what threat is posed by methane, both for the staff as well as the threat risk for the climate. We are trying to maximize the demethanization use and reducing its emissions to the atmosphere. The methane that's used for electricity and heat generation at the generation plants. At the southern KOMAG, this is done by PGNiG Energetyka Przemysłowa, whereas in the northern ones is the Żory plant and using our in-house systems. The goal of JSW is that the 100% of methane should be used for business purposes. Currently, at the northern command, there is a program underway to develop the cogeneration systems with a total capacity of 60 megawatts. Of course, in order to build such an installation, you need to build an auxiliary accompanying infrastructure such as the cable, bridges, modernization of the demethanization station and the main switchgear. The total amount of investment is almost 350 million PLN. Unfortunately, according to the directive European Union 2003/87, the carbon dioxide emitted during the utilization of methane in the cogeneration engines with installed capacity above 20 megawatts obligates us to participate in the EU ETS system and to incur additional costs for that reasons. It is estimated the above fees charges will lead to the increase of the cost of production by about 100%. This will cause a drop in the profitability of investment project. The program is planned for until 2025, and the idea is that the entire methane by the northern plants is utilized. For that purpose, 18 systems will be installed at the various sites of Knurów, Szczygłowice and Budryk coal mines. Also, the flows connecting, so the optimum distribution of methane will be taken care of. On these pictures you can see the investment project at Budry coal mines that were already completed. In forefront, you have the definitization station, then the cogeneration systems on the second picture, and next to shaft number 6 of the Budry coal mine. On these pictures, the coordination systems at Knurów coal mine commissioned in June 2020. Last year, in the coordination systems of the northern coal mines, as part of a methane utilization program, almost 26 million cubic meters of methane was utilized and almost 100,000 megawatt hours of electricity was generated. Our further actions aimed at reducing the methane emissions to the atmosphere can be covered by 2 items. First of all, the reduction of emissions at the headings. So the methane that is now emitted into the ventilation air, we'd like to capture into the ventilation system and use it for business purposes. We do, however, realize that it's not possible to totally avoid the emissions of methane to the ventilation air. Some of the methane will always go into the atmosphere with ventilation air, so therefore we need to gain technology that would utilize the methane in the ventilation, because it's difficult because concentration fluctuates between 0.2 to 0.6%. We are not surrendering, however, and jointly with Central Mining Institute, we are trying to implement things that have been already proven worldwide. But all these actions are very expensive without the financial support. It's not possible to implement them. If the European Union is seriously treating the methane emissions to the atmosphere, one should think about the tools for providing support. The first good step would be switch off the electricity generated from the methane fired emissions from the European Union ETS systems. Thank you very much for your attention, and please follow our actions on the website CMM Energy EU. Welcome, ladies and gentlemen. It's a great pleasure for me to be able to participate in the 21st International Scientific and Research Conference, Innovative Techniques and Technologies Friendly for the Environment. The topic of my today's presentation is the consequences of emissions of methane from the coal mines to the atmosphere, opportunities and threats in the context of last year's European Union strategy of European Union. My name is Łukasz. I am an employee of Politechnika Śląska in Gliwice. As an introduction to my today's presentation, I'd like to present the monography that I wrote, entitled The Economic Utilization of Methane from the Liquidated Coal Mines, which is the result and a summary of my multi-year research and practical experience regarding the obtaining and the business use of methane from the coal mines in Poland, hard coal mines, that I conducted directly at the coal mines, and the enterprises that were obtained the license for obtaining and operation and exploiting the methane from the coal deposit. And I'm currently continuing my research at Politechnika Śląska. This monography is a complete, comprehensive scientific compilation that covers the topics related to the capturing and use of methane accumulated in the coal mine, methods for shutting down the decommissioned coal mines, development of the tanks of methane reservoirs in the both active and shutdown methods for demethanization of liquidate coal mines, the ways to obtain the methane from the coal mines. In my monography, I also noted the need for the urgent and complete activities aimed at taking advantage of using the methane from the coal mines in Poland. Starting with this research was due to the directive from the business needs of coal mining as well as natural environment protection. The tests covered both the theoretical work and well as experimental work. A lot of those tests were completed finished or ended up with industrial implementations. For a number of years in the worldwide economy, there's a growing interest in obtaining alternative fuels, including the ones that meet the ecological requirements. One of those directions is the use of energy that methane contains. Methane in the coal deposits is a highly valuable thermal fuel. Its calorific value is about 3 megajoules per kilogram. The methane is emitted by both active coal mines as well as the shutdown coal mines. At the same time of liquidating, and as the coal mines are being liquidated and shut down, the potential for the business use of methane resources is growing as the awareness and of undergoing climate changes and the climate policy. The methane from the coal deposits has become subject of more interest and the business use. On the other hand, methane is a threat, poses a threat because it's the second most important factor that contributes to climate change. Over a 100 time frame, methane has a 28 times greater potential for the greenhouse effect creation than the carbon dioxide, and 87 times stronger in the 200-year time frame. Therefore, the emissions of methane are of major importance for the climate goals of the European Union for 2050. On the 14th of October 2020, the communication from the Commission of the European Parliament, the Council of the European Economic and Social Committee and the Committee of the Regions was published on the strategy of the European Union to reduce methane emissions. The strategy published on October 2020 is the second communication on counteracting methane emissions since 1996, when the Commission for the first time dealt with this issue and defined the first EU's targets. The strategy and legislation that will follow it is to enable methane emissions reductions by 50% by 2030 over next and climate neutrality by 2050. Reducing methane emissions is one of the priority initiatives as part of a European Green Deal. The strategy does not assume setting up the emissions trading system for methane. The specific consequences of the strategy will become more clear soon after the legislations are published. The activities proposed by the Commission are related to agriculture, waste and energy industries that account for up to 53, 26 and 20% respectively of methane emissions in the Union. But the main legislation will be aimed at reducing emissions in the energy sector. The Commission also to review the regulation on the joint reduction effort and to review the extension of regulation on the industrial emissions to cover the sectors emitting methane that are not yet covered by the scope thereof. According to the estimates of the European International Energy Agency, about 40% in the oil and gas sector of emissions can be reduced at the zero net cost using the available technologies. Of course, the obvious question arises how the European Union is planning to do it. Based on its communication, the conclusion can be drawn that the European Union is to become the worldwide leader in terms of methane emissions in all the relevant areas. In the first step, through detailed, accurate metering, measurements and reporting. An important element of strategy is the improvement of the measurements and reporting of the methane emissions. The level of monitoring is currently different, varies in various sectors and member states, and lack of data based on the actual measurements, difficult to implement the methane reduction strategy. In order to improve the standards for measurements, verification and reporting, Commission is to provide the EU funds and also support the creation of International Methane Emissions Observatory in cooperation with the Programme of the United Nations for Environment and the International Energy Agency. One of the tools used is to be the satellite program Copernicus, thanks to which one can supervise and detect the largest emitters and quickly detect places where such a leakage takes place. What's the situation like in Poland? Poland is a leader of a European ranking of countries emitting the largest quantities of methane from its coal mines. It's according to the latest report of think tank Ember. The leakage of this gas is more harmful for the climate than the emissions, for instance, of the carbon dioxide from the Bełchatów power plant. Polish coal mines and the largest emitter of methane from the originating from coal mines in Europe must accelerate the implementation of a plan to eliminate the full emissions of methane to the atmosphere. Let us have a look at the emissions of methane from the coal mines in Poland in 2020. The total quantity of methane emitted as part of exploitation of coal was more than 778 million cubic meters of methane. We're talking about the in absolute terms, which means that on average within a minute more than 1,500 cubic meters of this valuable gas fuel. In 2015-2020 time frame, the quantity of methane emitted converted into a ton of coal extracted net. We're talking about the relative methane content would fluctuate between 12.9 to 14.5 of cubic meters of methane per ton of coal extracted, net coal extracted. In 2020 it was exactly 14.5. On average, the average efficiency of demethanization in last year was 37%. Which means an increase by almost 1% versus 2019. The total quantity of methane included in the on-the-ground demethanization station at Polish coal mines last year came in at more than 291 million cubic meters, out of which more than 184 million cubic meters was utilized, and the balance was emitted irreversibly into the atmosphere. And thus, in total, in 2020, almost 605 million cubic meters of methane was emitted into the atmosphere. Let us move now to the conclusions and the recommendations. In view of the justified and growing pressure on the maximum limitation of curbing curtailment of emissions of greenhouse gases and placing emphasis on the energy efficiency, the use of methane from coal mines becomes fully justified. The tests completed indicate that the further process respect to the utilizing the methane from the coal mines and the curtailment of reducing of emissions of methane to the atmosphere are possible to be achieved, provided that several important problems are resolved. The first one of them is to intensify the demethanization of the coal mines in the underground coal mines. Secondly, to increase the methane capture through additional demethanization holes drilling above the needs related only to ensuring safety. Larger utilization of gas by the cogeneration systems based on the gas engines in order to cover the coal mines' in-house needs for thermal electricity and coldness, and to obtain the methane from the already decommissioned deposits. Further on, acceleration of works aimed at the final designing and building the pilot installations for methane utilization from the ventilation air, including the underground from the air conditioning of mining workings, and the underground above the ground based on the technology of intensifying methane from the ventilation shafts of the KOMEKO. One should also intensify the deriving of methane from the tanks of the liquidated coal mines, and this technology should be defined at the stage of designing the plan to liquidate the coal mine. One should also prepare the information based on the methane resources in the area of the liquidated coal mines and the ones that are planned to be liquidated. One should also amend the geological and mining law with respect to a further simplification of the open door procedure to obtain by the enterprises the licenses for exploration, recognizing and exploitation of the methane from the coal deposit in order to simplify the license process implemented at the Ministry of Environment. One should also develop appropriate economic conditions for the ventilation of the methane captured from coal by shaping appropriately the tax burdens and others. One should also take up actions with respect to educating the specialists that are dealing with the methanization and methane utilization from the coal deposits. The implementation of direction of activities above with respect to sourcing, obtaining and business use of a methane from the coal mines will definitely improving the safety of performing the mining works. Secondly, limiting the effects of greenhouse effects, and thirdly, obtaining benefits, economic benefits, financial benefits. Thank you very much, ladies and gentlemen, for your attention, your time you have to my presentation. See you next time. I wish you, first of all the health. Thank you very much. Good afternoon. My name is Kazimierz Buchta. I am the manager of mechanical processing coal plant, and along with the director of the office, Mr. Roman Węglow, we are the co-authors of a presentation entitled Implementation of Circular Economy at the Coal Mechanical Processing Plants at JSW. Please have a look at our presentation. Implementation of circular economy at mechanical coal processing units at JSW. The core function of all the coal processing units at JSW coal mines is the separation of primary coal and giving it the features, properties and parameters expected by the counterparts conducted, mainly the coking plants. The entire processing is industrial operation on large scale. The annual gross output is more than 20 million tons, and the net production exceeded 40 million tons of coal in 2020. The streams of feeds flowing into each of the 6 processing sites operating at 4 coal mines have very diverse properties. The quality desired by the consumers is in line with a broad range of parameters. The purity of coal, its ash content and humidity content depends upon the processing process. The coking features are a gift of nature, and the mechanical processing cannot change it. We can, to a certain extent, stabilize its averages and route to the individual streams of products for shipment, taking into account the quality expected by the consumers, taking into account the processing of millions of the commodity. The maximum use of its potential has an big importance, not only for the financial results of the company, but also for the big economic environment of the market of coal, coke, and steel, adjacent citizen communities, and our common natural environment. Let's have a look at each processing plant at Borynia Zofiówka. We have 2 plants, then the processing plant at the Budryk coal mine in Ornontowice, the processing plant of the Knurów-Szczygłowice coal mine in Knurów, the processing site of the Pniówek coal mine in Pawłowice. Knowing that the exploitation of coking coal resources of the highest quality in Europe, of Poland, JSW has its own limitations and is burdened with high costs. The processing units must not only minimize the losses of coal substance in the waste, but also seek to develop products of the highest quality. Concentration of mining, fine grain, a lot of distribution of output makes that the accessibility to leads to the situation where you have a large share of finest grain coal in the direct production. This leads to major problems, technological with respect to mechanical processing, also in the draining system. Also, the high proportion of fine grain content is not desired in the process of coking, in the aspect of highly durable metallurgical coke in the batteries of the system. For the circular economy is seeking to have a no waste production, maximum utilization of all the products, and the idea is in line with the processing units operation. Therefore, we are seeking to maximum utilize the coal sludge. We separate it in the flotation process, obtaining the pure coke. The process of draining of sludge is costly, especially with two-stage vacuum filtration through the membraneless thermal drying related to the large quantity of coal fuel as a source of coal. Therefore, the processing unit, except for Pneumatyki, change the draining technology into pure mechanical ones. The flotation considered in the sedimentation and filtering centrifuges was used, which allowed to eliminate the use of coke for in-house process needs, totally amid the emissions of dust and gas from the coal drying, enabled utilizing the non-burned coal for our purpose, simplify the structure and process, and allowed to reduce the headcount at the plants. As a result of the synergy of the above changes, further elements were achieved with accuracy for the circular economy, such as the general improvement of the relationship with the environment, improvement of the natural environment, reduction of the water consumption, and improving the comfort of the operation of the work of the crew, as well as the savings of the natural resources. Here we can see the machine for draining, so the sedimentation, centrifuge, open bowl, and the next stage aimed at improving the utilization of finest grain coal with below 25 micron is the installation of a high performance filtering presses, chamber and membrane filtering presses that solve a number of problems, enable to efficiently drain the coal from the suspension, get a content product that improve the structure of the input, and provide excellent filtering. The efficiency of the process is sufficient, so that the sludge product that was originally the waste, that was sold in the blends of coal for thermal process, now it's a fully valuable component of the input coal for the coking plants. And that's how the filtering chamber and membrane filtering presses, you can see on the pictures at our sites, more pictures of the latest machines, and the drained coal sludge, such as this kind of pie coming out of a press. Apart from the purely production activities at the processing plants, JSW is conducting a full review of the available technologies for draining, granulation, pelletization of a process for such a use of its potential, so that would allow our products to meet the requirements of the group's coking plants, and as well as other consumers, our recipients. We are part of a consortium set up by JSW Innovations, JSW Cox, and our company to implement the project underway, the technology of developing the densified component of blends for the system for mounting the coking chambers with use of a fine-grained coal fractions called further densi coal. The goal of the project is to develop a technology for developing the components of the coking plants inputs by densifying the coal blends containing the fine-grained fractions. The key subcontractor of the research part will be ICHPW in Zabrze, which will require a cycle of industrial and development works. A good example of the use of the coal sludge is the operations of composite solid fuels in Massachusetts operations unit owned by JSW Innovations. It develops the Varma Premium, the first composite coal fuel that allows for improving the environment conditions in metropolitan areas and tourist and health spa regions. It has reduced the content of harmful substances, including significantly benzopyrene. Additional area for the circular economy for coal sludge inherited after the operations of coal in the past decades and even ages is it's deposited in various settlements and tanks and basins. Is the seeping, drying and granulations. The positive tests in this respect were conducted at the Knurów plant. You can see on this picture a granulator pilot project installation at this unit, and here you can see the pictures of samples of a granulated coal sludge that is much better, more favorable form of coal sludge to be used by the energy sector. In cases where the capabilities for mechanical dehydration of coal are exhausted and its level of humidity content is not acceptable, you have to review the thermal approach. The best way would be to use the waste heat from other technology processes such as the coking and utilization of the process gases. Another advantage would be the drying of the coal just before coking, which eliminates the waste of energy in case if after the drying the coal was to be dumped. Another having very good prospects of implementation of the circular economy is the production of a natural aggregate from the post-mining shale called JSW mining aggregate, rock aggregate, according to the National Technical Assessment of a Product issued by the Institute for Construction of Roads and Buildings. It's up to now use is very minor, but has a lot of potential for development. It has to be changes in the up to now approach to its application by the business, which could be served mainly by the spreading of the knowledge by the universities, institutes, and promoting of its use in the purchase orders. Post-mining aggregate, rock aggregate, was used successfully in the construction of a viaduct on the road in Jastrzębska in the district Bzie towards the Pawłowice municipality. And other applications, among others, the construction of a Racibórz Dolny dam. You can see the model of a water facility below. Leveling works for various railway tracks, liquidation of flooding areas covered by the impact of mining exploitation, and the leveling of the land. In the individual construction projects, also on a larger scale, in the transformation of adversely affected by industry areas, implementation of circular economy. In the conclusions, we can say that the examples presented confirm that circular economy is functioning in many aspects at the processing plants. A large scale of economic efficiency is displayed by the utilization of coal sludges, and thus in the production of coal for the coking purposes. The local utilization of waste heat should be a priority in case of the need to dry coal or preparing the input for the coking process. Use of the circular economy solutions confirms the care for natural environment, the utilization and the recovery of waste in order towards the production of aggregates. A certain challenge that the company is facing, but also the construction sector, the research and scientific institutions, and the mining municipalities and located in the vicinity. Think of greater possibilities of a broader utilization of circular economy promotes the businesses with great competition and being perceived such entities as more corporate, socially responsible companies. Thank you for your attention. Ladies and gentlemen, welcome. My name is Juleta Sokoła-Szewioła, an employee of Technika Śląska at the Mining Faculty and Safety Engineering and Process Control Systems. In my research, I'm dealing with the protection of the post-mining areas, focusing on the use of the modern measuring techniques, metering techniques, and calculation techniques for observing the movements of terrain. For many years I've been conducting, and I'm continuing the connections between the information of land through the seismic activities. The co-author of today's presentation is PhD engineer Zbigniew Siejka, who is an employee of Agricultural University in Krakow and Politechnika Śląska. In his research, he's dealing with topics related to the precision and accuracy of the positioning using the satellite, GNOSS, geodesy, and the related disciplines. I'd like to present to you the results of the research related to the validation of the accuracy of a geodesic automated system, measurement system based on the GNSS platform for the needs of a continuous monitoring of surface movements on the post-mining land. These tests are related to the implementation at the Politechnika Śląska of a European project. This is a project called Post-Min Quake. This is financed from the Steel and Coal Fund and co-financed by the Ministry of Higher Education. It is related to the induced seismic movements and movements of rock mass in the post-mining areas. This is a very important issue related to the period after shutting down a coal mine. After a coal mine is flooded, there could be deformations of the surface land and seismic activity, and therefore it's important to research, test, and plans for implementing the long-term monitoring of a post-mining land in order to reduce the seismic risk and land deformation during and after the shutdown of the coal mine. The research assumed the monitoring of a continuous movement of surface near the GNS system in the vicinity of Kazimierz Juliusz coal mine, and the Politechnika Śląska is responsible for the performance of this project. Continuous monitoring was assumed to be conducted using various methods, satellite-based measurements, including the kinematic measurement, which is one of the differential techniques that uses the adjustments regarding the phase shift GNSS to determine the coordinates in close to real times. That allows us to achieve the high level of accuracy. The subject of a test research was to determine such conditions where such high accuracies could be achieved. The development of a navigational system, the current level, allows us to access 6 different positioning systems that in total provide access to more than 140 satellites, observation satellites, and those satellites are operating on various orbits. Assuming that each satellite is broadcasting, sending signals, observation signal on several frequencies, on average there are 3 frequencies, so we have an option to at the same time use many measurement frequencies and then choose the optimum solution. Therefore, we started research aimed at allowed us to adopt this optimum solution in our case. In the tests, we carried out measurements in 4 options, 4 variants. Variant 1, where we used in the measurements a single system. This is the GPS system, so the American system. In the second variant, we used in measurements the GPS and the GLONASS system, which is a Russian system. In variant 3, we used in measurements the GPS, GLONASS, and Galileo system, which is a European system, and in variant 4 we used 4 systems. So additionally we introduced here the use of Chinese leader systems, whereas on the previous slide you saw the table that included a summary of 6 systems. That there were also Japanese and the Indian system. However, we in our measurements, we resign from those systems because they are dedicated to be used in specific areas of planet Earth. If you look at the drawing, you can see that depending upon which variant, under which variant we are performing measurements, the number of satellites visible at the site of tests was changing. And in case of a GPS system, we were dealing on average with accessing to 8 or 9 satellites during the day, while in case we were using the last variant, we were accessing more than 30 satellites, while at certain time windows, during certain time windows, also access to more than 40 satellites. One should remember that when using the solution, such a solution where we are not just using a single system, we have a greater number of the total number of observation signals. Each such signal should be treated as a potential pseudo-observation, which in the process of equalization will be used to precisely determine the ultimate coordinates of a given point based on the generally adopted mathematical model of a solution. The conclusion can be drawn that, of course, a larger number of the correctly implemented assumed for equalization of observations has an impact upon the improvement of the quality of the final data obtained. We were performing the test using the special test database using 4 satellite receivers of new generation. These were Trimble R10 that are adapted to receive the navigation signals from all currently available GNSS system. The coordinates of reference points were determined, of course, ahead of time, independently based on the post-processing daily static observations. The test here involved the repeated determination of the same reference points independently using 4 different combinations of GNSS. So under the 4 variants that we assume, the basic information on the completed measurement is provided in the upper table. As you can see, we assumed the number of measurements per session of around 8,640, whereas in terms of the average conditions during the measurement, then of course the number of satellites observed was going up as the subsequent satellite systems were used, further satellite systems were used, and the EDOP parameter value was, PDOP was decreasing due to the use of another satellite system. The PDOP parameter value is very important because it's a spatial geometric accuracy coefficient for the range within which the tests were performed. The lower the value of this parameter indicates the better configuration of the satellites versus the station the position of which is being determined. If we look at this PDOP parameter value for up to the 3rd variant, this value was significantly changing, whereas in case of the 4th variant, the change was not very large. Results of the measurements was then subjected to analysis, and the absolute errors, relative errors, and root mean square errors of the individual performance, otherwise called random errors, for each of the 4 test measurements. Relative errors were calculated having eliminated, of course, before the systematic errors. However, the root mean square errors of a single measurement were calculated for 1 hour long independent time series of the observation. On the drawings you can see the distribution of errors on the x-axis for various variants, for variant 1, 2, 3 and 4. Similar distributions were prepared for the errors of x-axis ordinate and the errors of the elevation ordinate. The most important stage of analysis were the analysis of the random errors. Those analyses were performed for the x-coordinate, the y-coordinate and the elevation coordinate, of course, for the individual variants. In the table you can see the summary of the random errors for the x-coordinate, y-coordinate and the elevation coordinate for variants 1 and 2. When you analyze those errors, we determine that an average error of a single measurement in case of a single coordinate and the use of the first variant was plus minus 0.4 millimeter. In case of using the second variant was plus minus 5.9 millimeters. The random error in case of variant 3 came in at plus minus 4.5 millimeter. In the variant 4 it clocked in at 4.2 millimeters, so it was slightly reduced. The analysis regarding the random errors for the y-coordinate indicated that the first variant this error was about 5 millimeters. In variant 2 that error went down to 4 millimeters. In variant 3 this error went down to plus minus 3.3 millimeters. However, the introduction of the additional system, namely variant 4, did not lead to a significant decrease. However, it led to a slight increase of random error to 3.5 millimeters. With respect to the elevation coordinate, in the first variant we had quite a large random error. It amounted to roughly 14 millimeters, whereas in variant 2 it came in at around 11 millimeters. After connecting to the observation system, Galileo system, this error went down significantly, arriving at plus minus 7.9 millimeters, whereas the introduction of the additional system, namely the variant 4, led to an increase in that error to the value of plus minus 8.9 millimeters. To sum up, the use in the kinematic measurements of real time of additional GNS systems improves significantly the satellite conditions of the place of observations planned by us. It also has a direct impact upon the accuracy of coordinates determined. Our tests demonstrated the general rule that the average root mean square of decreases as we add an additional GNS system to the observation setup, and it allows us to obtain the accuracy in the region of several millimeters, as it was assumed in the plan, in the project, whereas this rule can be adopted up to variant 3. However, the inclusion of Beidou satellite constellations to observe the real time for our location at the current stage is definitely not justified. Our tests indicated this constellation did not improve the results of the measurement, even slightly worsened it. In some time frames it may be, of course, brought about by the fact that the vessel system not fully prepared hardware-wise to conduct the continuous measurements in real time. In this case, the addition of additional constellation can only extend the process of determining the position through ineffective consumption of computing power of a computer that's performing the process of a continuous determining of a position in real time. Thank you very much for your attention. My name is Jolanta Biegańska. I'm an employee of AGH University of Science Academy in Krakow. In my presentation during this conference, I will present my reflections on the recultivation and revitalization. That's the topic of the title of my presentation, recultivation and revitalization. What's next? Recultivation is a series of actions aimed at restoring the natural terrain and also achieving by the soil such a content of a substance that will be in line with the required standards. Such activities are aimed at restoring the terrain, the land that was degraded of its usable or natural values. On the other hand, the revitalization includes the process of recultivation, but also the process of the utilization, the utilization of the land, in order to enable the performance by that land of its use function. Talking about land, about area, we are talking about post-mining land that was transformed by the impact of the mining operations, as well as post-industrial land, because the post-mining land is an area as a consequence of mining industry operations. In the recultivation process, one should take into account the goals, such goals as eliminating the threats, risk for health and safety of people, restoring the land and water relationships, eliminating the impact on the environment also outside the territory of a coal mine, also taking care of the future of a post-coal mine land, and encouraging to better use of natural resources. On the other hand, in the procedures that are part of the utilization process, one look at two major tasks. First of all, indicating the area that was the territory that was subjected to degradation, and secondly, identifying the processes that had an impact upon the degrading of the land. This is a broader look where you look into the social processes, spatial, functional processes, economic and environmental ones. And this way you determine what causes the negative consequences on what impacted the cumulative effect of such development. The transformations of post-mining or post-industrial land you can see in three ways, in three directions. First of all, the protection of a culture heritage that's related to the given industry. Next, improving the environmental conditions, landscaping, land utilization, and utilization for business economic purposes. The opportunities for utilization are in line with the type of function that the given device facility will be performing. It could be residential facilities as well as shopping malls, office space, restaurants, hotels, or educational facilities, cultural facilities, as well as sports facilities, as well as in green land. Examples of utilizing or revitalization of post-industrial, post-mining land. There are many of examples. I have selected a few examples from Poland as well as from other countries. In terms of Poland, an example of utilization of former barracks So, namely, the revitalization is in Szczecin by Politechnika Szczecińska, currently in the former building of the barracks, the West Pomeranian University of Technology is located. Another example is the extension and the alteration of a destroyed train station in Stroń Śląski, and thanks to the revitalization, Center for Education, Tourism and Culture was established for the inhabitants of the Stronie Śląskie municipality, as well as for the municipalities that are both on the Polish and Czech side of the border. In terms of foreign examples from abroad, Gasometer City in Vienna is a good example of revitalization, where the gas tanks were rebuilt. So out of 4 gas tanks each with a capacity of 90,000 cubic meters built in former years, they were turned into residential, office and services premises. There used to be gas storage facilities here, but after the use of gas was discontinued from such storage facilities, and after there was a conversion to natural storage, those facilities were no longer necessary, were no longer needed. Only the outer walls were preserved, and the process of revitalization gave them a new life. Similar, the revitalization of a Battersea power plant in London, that was developed as part of the energy industry thanks to this power plant. But one should mention that in the 80s, last century, it was included as part of the national heritage of Great Britain as the largest building structure made of bricks in Europe. It was decommissioned, and thanks to the revitalization, the facility was turned into a complex of buildings. Ultimately, the facility has a park space, together with a local park, and the London Pump is to have a seat there. The revitalization of a shopping mall near Boston, a shopping mall, is the largest shopping mall of its type in the US. It stopped operating in 2008, and the building was altered according to the revitalization project. Instead of stores, small apartments were built, and the bottom floor, ground floor, the recreational and commercial space, shopping space. Poland, example of adaptation for residential purposes in the Upper Silesia, a former lamp facility of steel and mining conglomerate, Orzeł Biały, White Eagle. The single-family house was built in type of a loft. Such lofts are also designed and built in other places in Poland. In Żyrardów, Krakow, Gliwice. Another example is the rye mill in Szamotuły near Poznań. It's a modern addition that you can see. 2 residential floors were built, and on purpose the architect included in the old brick type facade a modern part was mounted, and it gained a extra special feature this way. Another example would be the cultural park of the city fortifications, Gdańsk Stronghold. The educational and recreation compound built after the revitalized fortification compounds set up a new tourist product. For educational and exposition purposes, 4 historical buildings were revitalized and adapted. Currently in Poland, you can sightsee about 20 underground mining workings, coal mines. So the mining infrastructure is the main aspect of the post-industrial underground tourism. There are tourist trails, coal mines, shafts, underground mining workings are being made available. They provide a new direction for tourism, growth of tourism called geotourism. People are motivated to search for post-industrial facilities in order to study history, get some education, experience new things, experience contact with the past, and also photographing, filming, videotaping. They approach this as an adventure. The areas utilized or not utilized are also located at some remote places. It's difficult, as a matter of fact, to find them on the map. Therefore, they require promoting, and this geotourism combined with a method for promotion that's called geocaching provides an opportunity to find such spots, such locations. That's why the question at the very beginning, what's next? The idea was to give a path, a way to motivate tourists to go on hikes, on trips to unknown areas. Therefore, promoting of such areas is very important, and geocaching is exactly what makes it possible. It's a mobile game that's based on GPS location that involves hiding caches, special containers that are placed in various locations, and the participants of a game, in this case tourists, are looking for such treasures, containers. They arrive at caches. The goal is, of course, to find the largest possible number of such containers, enter the fact of finding, making such a find in a paper register that's placed in this container, and finally make an entry in the internet web-based log. Because geocaching is by assumption a recreational game for setting up those caches, but the overall objective is to encourage the users to visit interesting places and, of course, attempt to find those hiding spots. When they arrive to such places, they get the display of information. A clear example of such industrial land is Tarnów brick factory, where an attempt was made to promote this area. The brick factory was made up of 5 buildings that at the beginning of the 20th century were operating on the territory of Tarnów city, and they were subject to devastation. They became redundant. At the sites of those brick factories you can find the buildings with tanks with water, the devastating buildings, and the chimney that's still there. As part of her graduate diploma work, a student made an attempt to set up such hiding boxes. Her intention was to promote the area that will be revitalized. She arrived at some remote spots. She set up 4 hiding boxes, caches. It's quite interesting spots. She placed them around trees, of course. In those boxes, she placed the so-called gifts to the persons that were included pictures of brick factories and minor items for the persons who first arrived at that area. It turned out that over a short period of time, she received in the geocaching service information that tourists were visiting those spots because there were entries made and sample comments addressed at the offer that may confirm the purposefulness of such actions. There were thanks for beautiful history, for the cache, for this gift, and the attachment, and the entries showing that there is interest in this area. In conclusions, I'd like to note that this form of promoting the post-mining, post-industrial territory, land, in the current times is definitely justified. Because if we do geocaching, tourists have an option to arrive at places and facilities that are not present in the tourist guides or are not a part of the travel office offerings. The network of caches or containers is distributed all over Poland. As far as I know, the interest is growing in arriving at such spots, but at the same time at getting to know the history and becoming acquainted with the given facilities. Geocaching meets all the criteria of cultural-based touristry because, first of all, the sightseeing is purposeful. Even short trips have a certain goal. The tourist attraction, namely the facilities, events, frequently is military facilities or nature-related objects or churches, and traveling increases the knowledge of a given area, both during the direct exploration or when finding the caches. Sometimes you need to solve some task to find the given cache, and you get the display of information on the given site. Thank you for your attention. Ladies and gentlemen, this way we have arrived at the end of the first day of the 21st International Scientific and Technical Conference, KOMEKO-IMTech 2021. Today we had the pleasure to listen to 17 papers on various topics. The main weight was placed today on the processing plants. We start with topics related to the issues and challenges that are being faced by the coal processing units of selected coal mines. Next, we covered the topics related to the improvement of efficiency of such units of mineral raw materials processing system, as well as recovery, obtaining of rare earth elements and the further utilization thereof in the manufacturing industry. The entire all the topics related to the processing systems we were able to summarize in the discussion panel. During this discussion panel, we had a meeting of the world of the manufacturers of the mining device and the producers of the raw material, the commodity of the coal. Our guests had a chance to speak about the topics related to the future of processing systems, expectations coming from the coal mines and the capabilities and the proposals of the manufacturers. Ending the topic of the processing systems, we moved on to the issues related to the current transformation of the transition of the mining sector. We covered the topics related to the utilization of a post-mining land from both social, administrative and organizational point of view, and all the problems we'll be facing in the near future. As well as in the final session we covered the topic of green mining, so the ultimate overarching goal that we are all seeking to accomplish. We discussed the issues related to the reduction of the methane emissions. We also covered the circular economy topics, as well as again, we covered an important issue being the utilization and the recultivation of the post-mining land. Thank you very much for participation in today, for the activity of all the listeners, for all the questions sent. Let me remind you that please keep sending those questions to the KOMEKO@komag.eu, and from this place I'd like to invite you to tomorrow's presentations, which will start at 9. That's correct. Tomorrow, ladies and gentlemen, we start at 9 o'clock. We will listen to 15 presentations as part of 3 sessions that will be first of all related to the safety, energy management, green energy, as well as innovative and safe solutions for the mining sector. Ladies and gentlemen, just like today, also tomorrow we have an important objective in mind. We want to integrate the scientific community, academic community, and the representatives of the industry, so that we can all talk, discuss, exchange views, and those 2 days of the conference will be devoted to these topics. Also be happy to see a lot of listeners to our presentations, and also we'd like to invite you for tomorrow, second day of the conference. Thank you very much.
Here I am in the heart of our Nord product range. Nord Drive Systems manufactures a very large range of drive technology products. Gear units, electric motors, electronic drive technology and industrial gear units. The overall portfolio is a unique modular system from which individual solutions can be created for our customers. Our most well-known drive systems consist of a motor and a gear unit, the geared motor. Our drive systems can also be extended by frequency inverters. Here we have a decentralized solution, also available as control cabinet version. The most complex systems can be seen here. They are used for higher torques or powers. Nord has therefore developed the Max Drive Industrial Gear Unit series, including various integrable components. The almost infinite combinations allow for a drive that perfectly matches the requirements. Let me show you an example. This drive system, consisting of industrial gear unit, electric motor and fluid coupling, is mounted on a swing base. You can also choose an IEC motor attachment, use B5, B14 flanges on the output side, mount a modular external backstop installation, and choose many more product options. Here is another example, a typical application, a belt conveyor drive. Consisting of electric motor, coupling solution, industrial gear unit with axial fan for achieving maximum thermal limit powers, mounted on a swing base. Realized from our modular system. Here is a typical application, a mixer drive, consisting of agitator flange, max drive industrial gear unit, IEC adapter for fitting a Nord electric motor, and a decentralized frequency inverter from Nord, vertically mounted from the modular system. And we also have the perfect drive system for you.
This is the 18th edition of the International Fair of Mining, combining 350 exhibitors from 12 countries, 26,000 square meters of space. Please join us on the stage.
Województwo śląskie oferuje wiele rozwiązań dla biznesu. Natomiast Międzynarodowe Targi Katowice 2021 to wyjątkowe wydarzenie. Dlaczego warto się tu spotkać?
19. edycja Międzynarodowych Targów Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021 już przed nami. To jedno z największych wydarzeń w Europie i trzecie na świecie. Spotkamy się już między 7 a 10 września 2021 w Polsce, w Katowicach, w Międzynarodowym Centrum Kongresowym oraz na placu przed Spotkiem.
Nadchodząca edycja targów Katowice 2021 została wzbogacona o Międzynarodowe Targi Energetyczne B2Energy-Poland.
Jako organizatorzy przygotowaliśmy dla Państwa ponad 60 000 metrów kwadratowych powierzchni targowej.
Katowice jako serce województwa śląskiego to miasto otwarte na biznes i przyjazne inwestorom. Znajdujące się w nim Międzynarodowe Centrum Kongresowe to wyjątkowy obiekt, który został wyróżniony jako jeden z najlepszych kompleksów do organizacji konferencji, kongresów oraz targów w Polsce.
Oprócz naszych targów, Międzynarodowe Centrum Kongresowe gości również 5. Polski Kongres Górniczy, Europejski Kongres Gospodarczy i wiele innych.
Dla przemysłu istotna jest branża energetyczna i elektryczna, która podczas targów IMTech21 Katowice21 ma doskonałą przestrzeń do prezentowania innowacyjnych urządzeń i technologii. Targi o charakterze międzynarodowym to świetna okazja do podjęcia współpracy z międzynarodowymi koncernami energetycznymi i odbiorcami końcowymi.
W odległości 100 km 3 duże lotniska: Katowice, Kraków, Ostrawa. Dojedziemy do Katowic szybkimi trasami i autostradami, jak również znajdziemy tutaj szeroką bazę noclegową, a tereny wystawiennicze okalają parkingi. Podczas ostatniej edycji targów gościliśmy ponad 350 wystawców i odwiedziło nas 30 000 zwiedzających, w tym delegacja z całego świata.
Jako organizatorzy wspólnie słuchamy i dopasowujemy się, by stworzyć idealny klimat spotkań do rozmów o kierunku rozwoju tej strategicznej branży. Rozmowy toczą się na płaszczyźnie krajowej i międzynarodowej. Organizator targów gości delegacje zagraniczne dzięki współpracy z miastem Katowice i Izbą Gospodarczą.
Tych wszystkich, którzy się jeszcze nie zdecydowali, zapraszamy na Międzynarodowe Targi Górnictwa, Przemysłu Energetycznego i Hutniczego Katowice 2021
oraz Międzynarodowe Targi Energetyczne IMTech21.
Spotkajmy się na targach od 7 do 10 września 2021. Katowice. Miasto przyjazne biznesowi.
Sytuacja na rynku pracy w sektorze górniczym jest i będzie bardzo zmienna. Dzieje się tak z przyczyn niezależnych zarówno od pracodawcy, jak i pracowników. Zmiany, którym górnictwo podlega, wymagają od osób w nim zatrudnionych lub poszukujących tam pracy nieustającego podnoszenia lub nabywania nowych kwalifikacji.
Spółka JFW Szkolenie i Górnictwo opracowała pilotażowy projekt górniczej aktywizacji zawodowej. Dzięki temu dajemy szansę górnikom, jak również mieszkańcom Śląska, utrzymania miejsc pracy w górnictwie. Szansą jest edukacja, czyli podniesienie lub nabywanie nowych kwalifikacji zawodowych w górnictwie.
Projekt Górnicza Aktywizacja Zawodowa GAZ, finansowany w całości ze środków Europejskiego Funduszu Społecznego, przeznaczony jest dla osób, mieszkańców województwa śląskiego, pracowników bądź byłych pracowników jednostek organizacyjnych spółek węglowych lub przedsiębiorstw z nimi kooperujących. Projekt przeznaczony jest dla osób zagrożonych zwolnieniem, przewidzianych do zwolnienia bądź już zwolnionych. Projekt pozwala podnieść swoje kompetencje oraz kwalifikacje zawodowe, zyskać nowe atuty niezbędne na współczesnym, dynamicznie zmieniającym się rynku pracy.
Projekt Górnicza Aktywizacja Zawodowa GAZ to nie tylko kursy zawodowe służące podnoszeniu lub zmianie kwalifikacji. Spółka JSW Szkolenie i Górnictwo wspólnie z Akademią Górniczo-Hutniczą z Krakowa przygotowały też studia podyplomowe.
Jednym z ważniejszych elementów projektu Górnicza Aktywacja Zawodowa są studia podyplomowe, które będą prowadzone w Akademii Górniczo-Hutniczej w Krakowie. Uważam, że projekt jest ważny i potrzebny społecznie, dlatego zachęcam do udziału w nim.
Szczegóły na stronie www.jswsig.pl. Projekt Górnicza Aktywizacja Zawodowa GAZ. Technologia VR, a więc rzeczywistości wirtualnej, jest narzędziem przyszłości edukacyjnej z powodzeniem wykorzystywanym już od dłuższego czasu w programach szkoleniowych spółki JSW Szkolenie i Górnictwo. Tamtejszy system VR jest tak skonfigurowany, iż może być rozbudowany o nowe komponenty edukacyjne. Najnowszym są fantomy, które współpracują z technologią VR, otwierając zupełnie nowe możliwości szkoleń z zakresu pierwszej pomocy przedmedycznej, a więc wiedzy i umiejętności, które mogą zdecydować o ludzkim życiu i zdrowiu.
Wykorzystywanie technik stricte praktycznych do nauki tak ważnej dziedziny, jaką jest niesienie pierwszej pomocy, pomocy przedmedycznej w zakładzie pracy, tutaj w tym przypadku, jakim jest kopalnia oczywiście, jest bardzo ważne. Wiedza teoretyczna, znajomości podstawy zachowania się w pierwszym etapie jest bardzo ważne, ale praktykę, ćwiczenie tego właśnie z wykorzystaniem aplikacji VR, z wykorzystaniem fantomów, prawidłowe uciski, prawidłowe sprawdzanie oddechu. Jest to najważniejszy element i stąd właśnie pomysł w Spółce Szkolenie i Górnictwo, aby rozpocząć szkolenia wśród kadr, którzy mają świadczyć tą pierwszą pomoc przedmedyczną, tak zwani sanitariusze, aby ich poziom wiedzy właśnie z zakresu praktyki, bo teorię mają, jak najbardziej właśnie z nich wykrzesać i sprawić, aby gdy dojdzie do niesienia pomocy, ona była jak najbardziej skuteczna.
Fantomy z aplikacjami VR pozwalają na indywidualny tryb szkolenia praktycznego, które jest dostosowane do umiejętności i predyspozycji każdego kursanta. Wirtualny instruktor precyzyjnie kontroluje czynności ratownicze podejmowane przez uczestnika szkolenia. Aplikacja jest tak zaprojektowana, aby podpowiadać kursantowi właściwy sposób postępowania z korekcją błędów do momentu prawidłowego wykonania czynności ratowniczej.
Na tyle będą wypracowane powtórzenia, aby nabrać tego prawidłowego zachowania. Także wykorzystanie właśnie aplikacji w tym zakresie, stricte udzielania pierwszej pomocy jest najlepszą teraz formą szkolenia moim zdaniem.
Fantomy z aplikacją VR służą nie tylko do praktycznej nauki resuscytacji krążeniowo-oddechowej, czyli sztucznego oddychania i masażu serca, ale także prawidłowego korzystania z defibrylatorów.
Jak go prawidłowo elektrody rozmieścić, jakie po kolei czynności wykonać, aby jeżeli będzie konieczność użyć tego defibrylatora.
Zalety wirtualnego systemu nauki pierwszej pomocy doceniają także kursanci.
Właśnie jestem po skończonym szkoleniu VR. Jestem zaskoczony możliwościami tego projektu. Aplikacja daje mnóstwo możliwości rozwoju umiejętności praktycznych.
Spółka JSW, Szkolenie i Górnictwo już teraz zaprasza wszystkich zainteresowanych zdobyciem wiedzy i umiejętności z zakresu pierwszej pomocy na bezpłatne zajęcia, które w ramach Dni Otwartych zaplanowano na czerwiec tego roku.
In production industries, there is a rising demand for reliable systems to monitor plant condition. Nord has recognized this need and produces predictive maintenance solutions to increase availability and make it easier to plan service and maintenance. Nord modular industrial gear units are available in 11 sizes with powers of up to 4,000 kilowatts and torques of up to 250 kilonewton meters. In our application test area, we demonstrate the opportunities of digitalization for gear unit operation and maintenance. On a test bed, operating states are simulated by two interconnected industrial gear units. The gear units are equipped with sensors for speed measurement, temperature monitoring, and intelligent vibration analysis. Among other things, this shows how unscheduled downtimes can be avoided, availability of plant and machinery can be increased, and their value can be preserved. Sensors record the necessary basic data for the Nord cloud solution. For example, they monitor vibration or temperature. Integration of other sensors, such as oil level monitoring, is also possible. Via the frequency inverter, the data are available for power and torque analysis. The data are processed by the frequency inverter with an integrated PLC or are sent directly to a gateway. Via the gateway, the data are then sent to the cloud, so that they are available for evaluation and analysis from anywhere in the world. To avoid unnecessary data traffic, the local intelligence ensures that data are only sent if their values have changed. The logged and analyzed data are available in a web interface. During a learning phase, the reference state is first recorded. Information from databases for the individual components is used for this. The operating state is compared with the reference state in real time using intelligent algorithms. This enables precise conclusions about the state of the monitored gear unit components, such as gears and bearings, in each stage. Warnings are automatically sent to the cloud if abnormalities are detected. This enables optimum planning of servicing and ensures the availability of the plant. This means that a deterioration can be detected before damage is caused. The application test area also demonstrates the added value of modern data analysis, even in plants without predictive maintenance. Alarm thresholds for faults can be set up to shut down the plant in case of an alarm. Detailed analysis of the data enables in-depth examination of the damage symptoms. The frequency analysis enables conclusions about the part which is causing the measurement change. Therefore, faults such as bearing damage or gear wear can be identified and localized. Predictive maintenance provides great added value for plant operators. Availability is increased. Maintenance costs are reduced and servicing can be planned more efficiently.
Nord Drive Systems has expanded its industrial gear unit product portfolio with a new product line. This gear unit can be especially effective for belt drives used in all areas of bulk handling. We are talking about the MaxDrive XT. XT means extended thermal capacity. As indicated by the name, this gear unit has an exceptional property. Compared with many other drives of comparable size, it has a significantly improved thermal limit power. That means very high drive powers without additional cooling can be used with this gear unit. Especially for the bulk material handling industry, this is a great advantage. The exceptional high thermal limit power is achieved by different devices. A heavily ribbed housing with a surface increased by the factor 2.5, a high efficiency axial fan, and a CFD optimized airflow with a corresponding baffle design. The area with the strongest heat generation on the drive shaft is hereby optimally cooled. A CFD analysis demonstrates the strong cooling effect and the optimized airflow, especially in the drive area. Compared to the MaxDrive gear unit, this results in a considerably increased thermal limit power. MaxDrive XT also follows the Nord concept of one-piece housings. This structural principle achieves more accurate axis positions, and the gear unit is more torsionally rigid. This results in significantly higher operational reliability and less maintenance. These unique properties perfectly qualify our new MaxDrive XT for belt conveyor drives. For these applications, Nord offers complete drive units consisting of gear, motor, coupling, brake and swing arm, individually tailored to the customer. This is the optimal solution for drives in mixing and agitation processes, optimized with leading companies from the sector for the sector. To illustrate the differences, let me show you which elements are not required anymore compared to the classic version. Wear-prone and therefore maintenance-intensive seals belong to the past, just like the bulky oil tank. Let's have a closer look at the new concept. Here we have a drive system consisting of gear unit, IEC or NEMA adapter, and electric motor. And this adapter makes the difference. We call it SOFOMI, sealless adapter for mixers. Compared with the old solution with an oil tank, the oil level can be significantly reduced and is approximately here. The lubricant heats up during operation and the volume increases. Thanks to the new solution, drive shaft seals can be omitted. When the lubricant heats up, the volume of the adapter can therefore be used to compensate. For you, this means excellent operational reliability, compact and simple design, fewer wearing parts, improved thermal properties, and hence less maintenance. Sofomi, always the first choice for new installations and with easy retrofitting.